Hello and welcome to the Lab Padre live stream for Starship's orbital test flight. This is going to be an amazing day. I'm crossing my fingers here. First off, you can notice that we've got a little bit of fog coming off of the orbital launch site here. It's coming from the, looks like the LOX side and the methane side, which are going through and cooling down the propellants before they load it into the vehicle here today. But we will go through and talk a little bit about what's going on, and I'll start off with basically Nate. Do you want to go through and give us a quick rundown what we should be seeing here today?
Sure. We definitely, of course, SpaceX has their milestones during the countdown. At 2 hours out, they'll conduct polls and verify propellant load, which I believe they already have done because they tweeted out that they were go for that. At an hour and 39 minutes out, they'll begin LOX load, liquid oxygen. Also at an hour and 39 minutes out, they'll also begin loading methane. A minute or an hour and 22 minutes out, they'll begin ship fuel methane load. And at an hour and 17 minutes out, they'll start LOX load for the ship. 16 minutes and 40 seconds before liftoff, the Raptor will begin chilling on the booster. At 40 seconds before liftoff, the fluid interfaces will begin to vent down. And then finally, at 8 seconds before liftoff, the Raptor startup sequence will begin. Once they're up to all up to the correct thrust at 0, hopefully, as they say, excitement will be guaranteed.
Absolutely. It's going to be an incredible day, one way or the other. So if it does not lift off today, we will still have a what's called wet dress rehearsal because all of the props have been loaded into the vehicle. And basically they can go through and test it, understand what the issues were that would basically prevent them from launching today. Right now, the only issue we might be tracking, we've got a question on. So, Phila Kid, do you want to pull up that question and what's going on here? And Nate, you have, I think, the answer for it, right?
I believe I do, yeah.
All right.
Anyway, good morning, everybody. It's Phila Kid here, along with Thomas and Nate. Looking forward to presenting a good show for you this morning. We have one question from Mohawk from Scotland. What is the weather like at high altitudes today?
The weather actually at the higher altitudes, which is mainly wind shear, is looking a bit better than at this point on Monday. And as the morning unfolds, the upper levels are scheduled to die down a little bit. Now, that doesn't necessarily mean that it couldn't cause a screw-up or whatnot, because there's a lot of other variables that can come into play. And they're not easy always for us to figure those variables out. But it definitely, from an upper level wind standpoint, is looking, at least from weather maps, it's looking a little bit better than Monday looked.
Well, speaking about upper levels, I've already noticed that the WB-57 is in flight and up at flight level 42,000 feet.
Wow, that's pretty good. So they've got about 8,000 more feet. And are they orbiting around the site right now, or where are they at location-wise?
They're only about a quarter of the way down from Houston, so they climbed up high real quick.
Wow. So for those of you who kind of are listening in and trying to understand, how high that is. So Mauricio with RG Aerial Photography, he goes up to 10,500 feet. It takes him a good about hour to get up to that point, and it's a Cessna 172. And yeah, that's a quite a difference. That's stark in contrast on that the WB-57 from NASA that's going to be coming down and observing the launch here today.
Yeah, if we get a shot of it like we did last on Monday, you'll notice Thomas noted the large wingspan on that. That aircraft was actually developed in Australia and adapted to U.S. Surveillance missions, and had extended wings added to it to give it extra lift, and the engines have been resized on it to give it extra power. So it can get up pretty high pretty quick and maintain a cruising altitude at up to, I believe it's published at about 50,000. I think it can, who knows where it can go after that. That's classified, I believe. But at this point, it's it's a high flyer.
Yeah, the best part about this is they have infrared cameras as well as just normal tracking cameras for visual colors. And so they'll be able to pick up a lot of amazing details as it's launching and lifting off. I'm hoping we get a live stream from them through SpaceX here today. Same thing for Hawaii, especially. So on that list of basically pieces, we haven't talked about the if everything goes right and is successful for liftoff and successful through. We've got max Q, MECO, which is main engine cutoff, stage separation, and then the start of the Raptors on the Starship. We should be able to see afterwards a re-entry of the vehicle, which will basically be the part we would be also looking forward to hopefully today.
One thing I'd like to bring up, Thomas, is to all the listeners, we'd like you to hit those like buttons. And if you have questions, ask at questions, and make sure you subscribe if you haven't already. I mean, it helps to get the stream up and running and keeps us here and gets us better cameras and more access. So the more you like us, the more the subscribe, the better off we'll all be as a group.
One thing that also comes up is there's a superstition every launch. I know that Gwen Shotwell has her own little superstition where she has to wear some shoes with a certain thing in them. It's just like a very interesting superstitious part. But for us, at least the superstition that kind of goes about is the more likes and subscribes and things like that we get, it seems like that's always what helps make these things go off successfully. So yeah, definitely hit those like, subscribe, and also share the stream to others because it's going to be an amazing and fantastic day. We're going to go through a lot. Some of it's going to be technical, but we'll try to summarize the little bit more technical questions at the beginning here for you as well.
Yeah, one of the things you may notice as you watch the stream this morning is it seems like there's a ton of fog on the ground, and it is a little overcast. But at this point, most of what you see is just various commodities coming out of the tank farm, the liquid nitrogen, liquid oxygen that they're using for chill down. It is foggy, but we're hopeful that as the sun rises, some of the natural fog will burn off, and we'll have a little bit better views here in a short order.
Yeah, it's just really suspending it.
This camera you're seeing right now is the Black Magic camera from Raptor that Lab is controlling.
Oh, this is Rover, I think, isn't it?
No, that's Raptor.
Oh, wow. Yeah, Rover 1 was just up a bit earlier, but yeah, this is Raptor. And see a light dimming off and on in the distance there. The fog is getting pretty thick at that site, and it's kind of rolling this way a little bit too. Hopefully, as Nate says, it burns it off, and we get to see a clear view of the booster and Starship today. And Rover 1 actually has probably the best view right now. Wow, look at that. So we did actually hear a little while ago at the T-minus 2 hour mark that they were go for prop load. That's why the countdown timer is running at the top of your screen. So that's based off of when they've said they're basically go for prop load and everything else, and just we're following their timeline schedule as well. So this is going to be a very interesting process here. So one other thing that we can basically go through and discuss is what we expect to see for like our views of the flight today. At least during the live stream here, we're going to go through and going to cut out into SpaceX's live stream occasionally and then cut back and forth a bit because we're going to go through and listen to their commentary and then also give additional commentary. But mostly we're listening for Innsbrucker. He has really good details on what's going on live on the ground, and he's kind of the I guess you could say most up-to-date information where everything else is kind of pretty much what we kind of already knew and understood already, but it's a good way to start off as well for those of you who don't know much about the Starship program. You could listen to their live stream as well. But this is going to be just an incredible day.
Thomas, I have a question here from Alan Lawrenson. What happens to the fuel when it is recycled, and why so many tankers if they are taking it back from the rocket?
Okay, so what we're seeing right now on screen on Rover 1 is a perfect example of this. So you have plenty of this kind of fog coming up. That's actually water condensate in the air that's being basically initiated by the cool down of all the nitrogen and the oxygen that they dump into the air. So they are going through, they have to pre-chill all the lines. And that basically comes up to the point where they, even though recycle, let's say the methane side, they recycle as much as they can. A lot of the basically the oxygen and nitrogen side are basically dumped out, and so you have to go through, bring in tankers. We counted about 41 coming in the other day that were basically just for basically replacing all of the commodities, specifically that we're seeing used right now to go through and do, and that's about $200,000 worth.
Yeah, I can give you a semi-accurate count of tankers. Since the scrub, there's been not quite 10 methane tankers, a little over 30 LOX tankers, and almost 80 LN2 tankers.
Oh, wow.
Yeah, they use a bunch of LN2 during the process because it's the principle. It's what they use to chill everything else down. So they go through quite a bit of LN2, and then of course they capture as much of the methane as they possibly can. They try to recycle it, and so that's a good sign that they only had to have just a few tankers to top off.
Yeah. What's their maximum capacity on tankers that they usually, in order to, let's say, go through and fill up the full fuel farm or anything like that? Do you have those numbers?
I do not have those numbers right this minute. I do not.
Okay. Well, that's just a question we can go through and answer later then. Do we have any other questions we can go through now?
Yes, Sarah KB7. Will the atmospheric gas, will the water, will the gaseous dehydrogenated monoxide disperse by launch time?
Dihydrogen monoxide is H2O. It's just water. I'm hoping that it'll be basically kind of burn up a little bit here by launch, because one thing that we have is the sun's coming up right now. You can actually kind of see that, I think, the sun right through the fog on the Rover 1 cam. You can't quite see it here on NateZ cam, but that sun's coming up and is going to start heating up the atmosphere. Oh, this is lab cam. Oh, I'm sorry. So it's just right next to the NateZ cam. But yeah, the view is going to be just as amazing here, and it looks really good right now. So that fog's probably going to burn off as it heats up the atmosphere from the sun. So that's going to be a pretty good view, I think. We'll still have a little bit of fog maybe towards Rover 2, but once they stop basically going through doing all their chill and moving all the commodities onto the vehicle, they basically stop all of the activity at the fuel farm. So all of that fog should die down, and we'll have a perfect clear view as well of the vehicle at liftoff.
Thomas, going back to commodity numbers, it looks like from what I can gather, this is a document that Grandpa Joe put together quite a while back, but seemed to be accurate. The farm can hold around 269 methane deliveries, 393 LOX deliveries, and 263 nitrogen deliveries.
Wow. That actually is interesting, because the nitrogen side is the one that they seem to be going through the most of. So it seems like they would need a little bit more on that side than some of the others, but they do use up a lot for LOX, for basically the booster and Starship.
They use LOX to cool so much of the pipe work ahead of time. So yeah, it's neat to begin understanding how some of this works and just how much it takes each time they attempt to launch.
Looks like we got another question come up here. Let's go with that one from Sasha.
Did they reattach the chopsticks to the ship in between Monday and today, or was it left standing on its own?
Yeah, so they did go through and connect the ship together with the chopsticks to hold it in place, but they do not hold it while it's being loaded. So in this case, we have it in its launch position. It's like a T pose, where it's kind of the shape of a T. And that's the perfect position to be in for launch readiness here. Another way that you can say that it's an issue if you, let's say, connect the ship, let's say like a strongback, with those chopsticks, let's say during the loading phase of their propellants, the propellants themselves cool down the ship and weigh significantly enough that they would actually damage the chopsticks, because the vehicle itself will shrink about 14 to 18 inches during that prop load. If you, let's say, were to look at the nose cone at the very tip, it's going to basically shrink down that amount. And so those chopsticks would have to basically be almost in like a float mode, which kind of puts it in a position where it doesn't actually do anything useful at that point. So yeah, they go ahead.
Oh no, go ahead. Finish your.
So yeah, they just put it in that T pose so that during launch it doesn't get basically destroyed by the flames from the Raptors, the 33 of them that'll be ignited during launch here.
If you look there at LabCam through the 6th kind of tower segment, you can see that we are beginning to see methane in the booster. There's a frosty spot.
Oh wow, yeah. It looks like we're recentering the cam here with the fuel farm as well. But yeah, you can see there is looks like methane being dumped off the integration tower. So where is that on our list so far?
Well, that Thomas, isn't that actually liquid nitrogen on doing the chill on the risers?
So you can get some liquid nitrogen dumped out of there, but sometimes we'll have methane dumped out as well. So it will basically go through, do both, from my understanding. But we hopefully will be able to answer that here in just a little bit as well.
Yeah, we should be right before LOX load for the ship, or methane load for the ship. We're not quite there yet. We're past booster LOX and booster methane loading. They're both underway.
Awesome.
And you can see they're getting the ship QD and the tower ready for a ship load with all the venting.
All right, and so we do actually have somebody who can go through and answer this question a little bit better for Stage 0 infrastructure. We've got Stage 0, Zach himself. Hey, Zach.
Good morning. Zach. Good to see you all. Hopefully my mic sounds all right. I'm outside with the lab right now. It's a bit windy out here.
I can see that. Oh, we can see the sun finally cropping up over the fuel farm now on the left-hand side. I was expecting on the right-hand side on this camera view. So Zach, we're talking about the basically the condensation we could see coming off the back of the tower here, back behind the ship QD arm. What is that typically?
I think that should actually be liquid or oxygen. So it's pretty much the same process that happens with the launch mount, as far as using the liquid oxygen to chill the pipes down before they actually start loading fuel. So they should be dumping oxygen or gaseous oxygen out of the tower until the fluid level actually reaches where that vent is, and then they close the vent, and I think they open up another one on the QD. I actually did not see that last time, though.
Yeah, I'm actually seeing that we've got two of them going on now. So there's one that was on the left-hand side, which I believe is the methane side, and now we're seeing the one on the right-hand side open up now too. So I think that one on the right-hand side was the LOX. Does that sound right to you, or does that go with what you remember?
Oh, so if there's two vents, one on the tower and then one on the QD, and they both actually do the same thing. The methane actually should be recovered. So the same process that's happening with the liquid oxygen is actually happening with the methane at the same time. It's just not visible because usually they're going to try and recapture all of that. Definitely a good idea to not have those two mixing in the air.
Yeah. So we do have confirmed prop load on the ship and booster right now. So we are loading. We can actually see through just the right-hand side of the tower, you can see these white little spots that don't quite change. Those are the, I believe, the ice rings forming on the booster. And then the ship is going to be a little bit higher up, just basically where all those chopsticks are out. You can kind of see, looks like maybe a bit of a white frost line on the bottom of these chopsticks here. That should be where the LOX line is, that you can see just a little bit of white there. I'm not sure if that's the prop load there, but we do have confirmation that it is being loaded on both the ship and the booster.
And Thomas, you can also, on occasion, see the venting from the top of the LOX booster tank shooting off the right side of the OLT about halfway up.
Yep. I've been watching that for a while now. It's
That's
very
actually
hypnotic.
it's pretty impressive. Sometimes without having a camera or a microphone near it, you don't really hear all the booster venting. But I actually had a chance to review some audio from Andrew Keating recently, and um, you noticed way more venting than I actually ever noticed before. And it kind of seems like, um, they're constantly releasing the pressure out of those tanks. So, if you kind of think of it as uh, actually, I don't really know a good comparison for this, but so both tanks are filled with gaseous nitrogen, I believe, to pressurize them, and so as you're adding in your liquid propellants, you're building up pressure at the same time. So I want to say it's almost about like every 30 seconds or so, um, they'll actually open up the tank to release some of that pressure, and then as they get deeper into the propellant loading process, the timing in between those vent releases actually gets shorter and shorter and shorter. So
Speaking of
if
one,
you're
you just happened just now.
yeah, if you're analyzing the audio, you can actually determine their propellant levels just based on the frequency in between their depress vents.
Wow. Yeah. So it did a depress vent here on the top of the LOX tank. So we should basically see that occur more often, as you're stating. Closer to the prop fill, it's going to just keep doing that. So one thing that's happening as the booster is basically has the propellants in the tank, it's going to warm some of those propellants up, specifically the LOX side. It's going to boil off from the skin of the vehicle, and you've got to get rid of that pressure somehow. So that's how we're seeing the vents constantly going here.
Every guys ready for a couple questions?
Shoot away.
Yeah.
First question from Marazam X. Is the fog expected to lift by T minus? And I think as the sun gets higher in the sky, we'll get the temperature heating up, and I think we will definitely be fog will be dissipated before launch, I think.
Yeah, and ultimately we're not they're not even under a fog advisory or anything at Boca Chica. This is just low level clouds. It's not truly fog. So as the sun comes up, it should burn off some. And like we said earlier, a lot of the problems we're running into with the cameras is just the sheer amount of commodities that are vaporizing as they chill and load the booster in the ship.
Yeah, I'm actually just looking at comparing it before and after right now. You can see the sun on Rover 1 and even LabCam right now. It's basically getting brighter and brighter, meaning that you can actually see through it a lot easier than you could before. But yeah, as the sun rises, you're going to just burn that off. And if the moisture in the air is going to basically be, instead of it being cooler as it is right now, it's going to warm up and you're not going to be able to see it as easy.
Another question from Mohawk. What are the commentators' speculation or crow for the percentage of chance of a successful flight completing all the mission objectives?
All the mission objectives. I'll go with 40%.
Are we considering all the mission objectives? Are we talking about a successful splashdown?
All the mission objectives. That's the part there. Like you would have to hit every single one to get all of them.
I'm going with 5%.
Wow.
I'm gonna revise mine to 25%. I'll be a little optimistic.
I'll go 50%. Just flip of a coin here. So I think there's a couple other objectives that there are, or quite a few objectives that they would like to meet. So as long as the ship gets into position to be able to be orbital and basically in 0G, I kind of suspect that they will be doing a methane header tank to main tank transfer of propellants. That's a big one. I think that's going to be on their list because we do know that from their previous live stream that they are loading header tanks, plural. And so one other thing we know is that their documentation says there is nothing in that methane header tank when it belly flops or splashes right into the Pacific Ocean. So that's one objective that they'll have to meet in order, or to meet, they would have to basically be in 0G. The next one is, I believe they actually do have 5 Starlinks on there. Even though there is no payload, there's nothing they're going to deploy. It's the equivalent like of a block of cheese. It's not much of anything useful, except for this case, It's a bit of dummy weight, and it's also useful for, let's say, your Pez dispenser. You'd be able to basically run it up to a point where they currently have a door that is sealed and welded shut. And if those Starlinks that I believe are in there basically could be used to run into the door and say, yes, it failed successfully. It is something that I'm expecting that if there's any good news, that would be the best to hear. But yeah, they need to go through and do that re-entry part of the test, which is really hard. And we've got some super chats coming up. So Phila, do you want to go for those?
Sure. Grubby, $11 Canadian. Thank you for being on the OGI on Starbase. You've done a historical important work. And Mohawk from Scotland, 10 pounds sterling. Root beer for Lob Padre.
Thank you, Mohawk and Groob.
I think one of the things I've just noticed on the OLIT is that one large vent that had been spitting out gas has transferred to liquid popping out of it. And now this second vent that's on the southwest side is now also venting, looks like liquid more than gas.
Yeah, I've got an interesting thought on this is going through and using nitrogen to go through and purge the system, liquid nitrogen to purge the system and cool it down. You'll have an interesting effect on the ship and the booster. And in this case, it would be for the ship. That if you basically have any nitrogen in there, its boiling point is going to be much higher than, let's say, the methane or liquid oxygen. And so it'll basically boil off and take any heat with it very quickly. Whereas the ship and the booster will basically be filled up with methane and liquid oxygen. You basically just vent off the nitrogen off the top of those vents. And that's another way of helping remove any of that as a, let's say, contaminant in this case.
Another couple questions here. Abito R&R, have they said if they would collect the booster and ship after it lands in the sea?
Yeah.
So go ahead, Nate.
Yeah. So the booster, they're going to attempt a simulated landing or hover right above the ocean. At that point, they're going to ditch it into the ocean and command valves to open so it'll sink. Their last kind of ditch effort, if it does not sink, is their launch license said that they would shoot it with firearms. So they're going to sink the booster, and then the ship is not even going to attempt to land. It's going to do re-entry and then belly flop into the water a little northeast of Hawaii. So the ship should obliterate itself when it hits the ocean.
Yeah, I loved the booster part of that that documentation. They said they would shoot it, possibly blow it up, possibly ram into it with a boat or pull on it with lines with a boat to get it to rotate so that it is closer to the valves so it ingests water properly. There's all sorts of planning that they have to make that booster sink. That's going to be a very interesting process, and hopefully you get to witness some of that.
That could make some great video in itself to watch.
Yeah. So I know that Mauricio, as soon as the launch is basically been completed, he's going to go through and do a quick flyover and try to see if he can get any shots of this booster floating in the water and what's left of it. So if there might be a debris field, he might be able to get some of that. What was that, Zach?
I have a confession. I'm going with Mauricio on that. So as soon as this launch is, as soon as we hear that the booster's landed, well, I don't know how long we're going to wait to head out, but we're going to go to the airport and see if we can fly out and try and find it out there.
Yeah, so you should wait for the booster to splash down before you make the run for it. But
yeah, I'm hoping that they don't try and sink it immediately. I'm assuming they would at least want to get out there and take some pictures for themselves of it. So hopefully that'll give us time to get up there and grab some images of it before it sinks.
Yeah, we'll hope that they're still focused so much on the ship that they'll forget about the booster long enough for y'all to get out there.
Right?
Yeah, and good luck. We're all counting on you.
It's going to be exciting, that's for sure.
And I want to remind everybody to like and subscribe and I'd like to see those like numbers come up, guys. Come on, there's a lot of people watching. We want to see more likes. And it certainly helps out the lab stream get published and get us out there. And we're hopefully putting on a good show that it's well enough for you to like. I have a question here from Kevin Ryan. Do they reuse the fuel once it's loaded, or do they vent it to the atmosphere?
Zach, why don't you answer that question? Because that's kind of your thing. You are stage zero, Zach.
Oh, sorry, repeat the question. You said, do they vent it after it's loaded?
Do they reuse the fuel once it's loaded, or do they vent it to atmosphere?
I'm guessing this is a question related to like detanking.
I think you could reference the detank. Yes.
Yeah, I mean, so if they do have to do a detank, it'll be similar to Monday, and most of everything is recovered. So the liquid methane is the one that they do the most recovery on, because they're actually reprocessing it before they add it back to the tanks. So they're collecting both liquid and gas on the methane side. For the liquid oxygen, most of that is recovered. It's like basically uses gravity to drain back to the tanks. And then there's a small amount of it that's not able to be recovered once the level of liquid oxygen in the storage tanks is higher than what's left in the bottom of the booster. So once they reach that point, I don't think they have the ability to recover the remaining propellant in the bottom of the booster tank, which is why they typically have to resupply with more liquid oxygen at the tank farm if there's like an aborted launch. So liquid nitrogen and liquid oxygen both are consumed in pretty large amounts, whether they launch or not.
I think that is reflected in the number of tankers that came back. As Nate said earlier, there were many more nitrogen tanks than there are oxygen tanks, and very few CH4 tankers.
Yeah, one thing to add to that real quick is I've noticed that at the beginning, they go through and do that whole purge of the system. So they're throwing away a lot of that LN2 and liquid oxygen. And then at the very end, they kind of do the same thing. And I kind of have a reason why. I was looking this up yesterday, trying to figure out what the density of water is when it's frozen as ice and compare it to liquid oxygen. And what they have is a funny little problem that the ice wants to float on top of the liquid oxygen. So they have to purge that out at the very end, just in case there's any water ice. They don't want to send it back through the lines. And we do see them go through and do quite a bit of a purge there. Oh, and that was a beautiful view. And now we've got Raptor Roost view with the vehicle, but it's kind of quite in shadow at this point. There's plenty of fog between you and Raptor Roost. Zach, how does it look from your position right now? Is it a little bit better, or is it still just as foggy?
Clearing up a bit. It's clearing up a bit. It looks like I can see the full stack in the tower right now. It's definitely a little bit hazy. My camera's got a decent view on it right now. But yeah, I mean, I'm hoping that it clears up. The clouds are starting to roll in right now. Actually, they were a little bit. They were clearing up earlier. It was actually clear sky, and then only the launch site.
Yeah, and we can actually see really well on from the Raptor Roost view, and now through kind of the tower that you were looking at it. We can see that line of LOX and methane really going up higher on that booster here. So we've got at least looks like two segments of the tower that it's creeping up there. Can you confirm on your side as well?
Yeah, sorry, and I think I may have been muted there, but yeah, it is. So the clouds are rolling in, but the fog near the tower is actually getting a little bit better. We can actually see it decently well right now, but it's definitely pretty hazy. The clouds are really low right now, which is unfortunate. I have a feeling we may have a little bit of trouble trying to view it once it clears the pad.
Yeah, it definitely has SN15 vibes at this point in time.
Yeah, I was there for SN15 with Phila Kid, and it just went up into the clouds, and then we had no idea where it was. It was quite a scary thought to say, well, it should be on track. We didn't hear anything explode or go off, so we're crossing our fingers, making sure, hoping that it's continuing all the way up, and I could just only hear people in the background saying that they've got a live view of it that keeps cutting in and out on their live stream from the view of the vehicle, and I didn't know exactly where it was, but I was just looking at that back staircase next to Raptor Roost and my friend Chuck, and thinking I'm going to have to probably grab him and bring him down the stairs if I see this thing coming in the direction I don't expect it here. So it was quite an interesting experience. But once we saw it come back through the clouds, when it did the whole flip maneuver, that was beautiful. And this time we're not going to be able to see it come back to the launch site. This is the full integration stack of the ship and the booster first time, and it's going to be pretty much close to orbital, but not quite orbital. So that's why it's a Starship test flight versus a orbital test flight. It's kind of close to orbital, but it's not. They get to the speeds, but not the basically the same trajectory.
The one thing that Thomas, in his explanation of the rocket going into the stars, forgot to miss, and it's probably the most important thing about a rocket launch, is that you feel the engine pressures on your chest. And at Raptor Roost, the ground was literally shaking, and the Raptor Roost itself was like a class 4 earthquake, which I have experienced out in California many times. So it is really a physical thing as well as a visual thing and a hearing thing. Every sense is affected by these flights. You've got to get to one someday.
Yeah, even if it's a static fire that's on the ground, you have to go. So there's one near Promontory Point, Utah, that I go to they did the SLS 5-segment booster that they have there, as well as a GEM 63XL. I got really close to the GEM 63XL because it's quite near the public road. They do not close it. And I went through and measured the distance, and it was about 0.8 miles away. So it's something where you basically feel it, as Phila Kid said, shaking your chest. Quite incredible.
I have a super chat, Thomas, here from Pre-Toast for $5. He says, more like, guys. Let's get more likes, please.
If we get a couple more likes, I think we can bring Lab on board here as well. So get a couple more of those likes. Oh, there we go. Thanks, Lab.
What's up, guys? Hey, Thomas. What's up, team? How y'all doing this morning?
We're good,
doing
Lab.
excellent.
Morning, Lab.
Morning. Yeah, we have quite a bit of haze out and very low cloud coverage right now. It's probably 2,000 or less. So I don't know how the tracking's going to go this morning. I was hoping that the sun would burn it off, but it doesn't look like it's going to. What do we have, about an hour left?
I mean, almost
Exactly.
not.
Exactly 1 hour left. So, lordy.
Yeah, they will launch through the clouds. That's one thing that it's always unfortunate, but it happens at Vandenberg all the time. They did it with SN11.
Oh, yeah.
It's pieces, rest in peace. And they even did it with SN15. So, the clouds are not an issue. It's really the upper level winds that they're kind of useful in removing some of these clouds, but these are actually lower level winds that we need to remove the clouds here. So we've got just beautiful views from Lab Cam and back over here at Raptor Roost. It's just kind of unfortunate that you've got that fog that's just right behind it and right in front of it that's obscuring the view, but I can pretty well make out they've got almost a third of the propellants in the booster now.
I have a question here from Bob Robert. How do they cool the engines on Starship when it is attached to the booster?
So you're saying how they cool the engines on? Okay, so the engines themselves, they have a feed line that goes into it from basically the ship QD, and then it goes actually through the main tanks of the ship as well. So I think it was like T-minus 15 minutes, or maybe it was a little bit less than that. They will go through, put liquid oxygen through the engines to basically cool it down. And that's what you're basically talking about, is the cool down for the engines. And then it will go through these pipes on the outside of the vehicle, and then goes down to some other pipes it's just barely connected to. that are on the booster. So it just redirects all of that liquid oxygen. At first, it starts off pretty gassy, and then it starts burping a little bit, and then it starts going basically just full flow of liquid oxygen. It has this kind of blue tint to it, but that's basically how they go through and do the engine cool down for the Starship.
Yeah, if rover 2 wasn't so fogged in at the moment, you can see that taking place right now. They're beginning to chill some areas of the ship, and so they're you can see the liquid oxygen beginning to come out of those pipes on the side of the booster. But it's rover 2 just is a wee bit foggy.
Yep, I only see our favorite Palm Bert. I think that's Bert, and then Ernie should be the one to the right that we don't see. We can barely see the top of the integration tower and the top of the ship right now, but I do think we should get a quite a bit of the clouds basically burned off here, and hopefully in the next hour it's going to be really kind of a close one here.
Yeah, I'm watching that cloud line at that's along the shore. It looks like it's moving northwest or northwesterly. So I think we're going to get the low clouds cleared out of here before the launch.
Yeah, it is. The flow's northwest, and I was looking at some of the cloud forecast maps here in the next hour or so, and they have the low levels possibly clearing out. The upper level clouds aren't going anywhere, and there really aren't any mid-level clouds. If this low level hanging clouds can blow out of the way, we may get decent views on the way up. It's just going to be timing. That's what it's going to come down to.
And the WV-57 is on station above Starbase.
I've got an amazing view of a bunch of friends of ours. I see Lab there at the bottom of the screen. Oh, it's just a beautiful view.
There's the mayor and
Zach, where are you at?
Zach, wave your hand. You should be back there somewhere. Don't see you.
Yeah, I'm off screen right now. I don't think you guys can see me. I'm over here waving my hand. I don't know if you can see that. Having to reach
jump
over
in front of
this,
those cameras. No, this is actually the second story of this building that you're at, so I don't think you can jump quite that high. There it is. I see your hand there.
You ready for another couple questions?
Yeah, let's do it.
The one and only SpaceX, the first company that tries to start the engines from the ground infrastructure. Did someone else do this before?
Was that?
I mean, it's according to how you consider starting. The Soyuz actually starts with, for no better word, giant matchsticks like you would start a model rocket still to this day. So, but I guess in the sense of how SpaceX is starting it, yes, it's very unique. Zach, you could really answer this question well, because this is, I think, what kind of caused you to dig into Stage Zero when you saw the launch mount and listen to Sam Patel talk about those booster QDs. So, Zach, you could probably really answer this well.
Yeah, so the booster QDs, as far as sorry, we're talking about booster QD or the Raptors?
Just the fact that Stage Zero starts the engines, starting the engines and spin up with the ground infrastructure.
Yeah, I mean, that's definitely one of the more amazing parts. I mean, so I guess the whole goal there is just to reduce the amount of mass on the actual booster, as far as the COPVs that are needed to start up the engines. So I can't remember the actual count of COPVs on there currently. I think it's 10 of them, 5 on each side, I want to say. I could be wrong about that, but if they didn't have the actual launch mount doing what it's doing, then they would probably need about 3 to 4 times that amount. So they're basically, making the launch mount part of the actual vehicle itself, which is pretty amazing. I don't know a ton about a lot of other launch structures, but the ones I do know about, I'm pretty sure this is the only one that's actually you could consider to be part of the vehicle itself.
Yeah, the only other structures I know that start a vehicle anyway would be solid rocket infrastructure and the way like Soyuz is started through the pyrotechnics. Other than that, when it comes to spinning up a actually liquid fed rocket motor, I don't know of anybody else that's ever done it this way.
Yeah, so I think the other launch vehicles will use ground infrastructure, at least for the spin start. They will basically provide pressurized gases to the vehicle itself. Some of that stuff they wouldn't necessarily need to have COPVs on their rocket because they're not reusing the rocket. They're just throwing pressure at it, and they just need to basically start it up, and then they just let it off, and it's up to the vehicle and the engines to basically keep itself going. So that's going to be the best way to look at it is that most vehicles, I think they do have that spin startup. The only other company I could find when I was looking through real quick was Spin Launch, but they're just spinning their rocket itself.
Animal.
Anyway, I have some super chats here, Thomas.
Yeah, let's go over those.
Kevin Matari, $11 Canadian. 55 Chevy Guys Underbar Steve, $10 US. Marilyn Morgan, $20 US. Dingbad, $5 US. Let's get the party started. And Dan Kerman, $10 US. Free Stumpy.
Thank you all. Appreciate those donations.
All right. Do we have some other additional questions we can go through as well?
Sure. When they first light the engines, will they be at 100% or lower?
It looks like they're going to be lower than that. So Elon has mentioned before when they did their static fire event, they did attempt at 33, but they only got 31, which was the world record at this point, beating out the N1 rocket that he loves to compare the Starship to, because there's a lot of similarities there. But the rocket itself has the thrust basically brought down to about 90%. So I kind of expect the same thing there. So in order to not damage the infrastructure nearly as much, not put the booster and the ship as much stresses as well, about 90% sounds about right. So instead of it being a thrust weight ratio of about 1.6, you're looking at the beginning of thrust weight ratio of about 1.4, if that's the case. And then they're going to go through and ramp it up as they're basically lifting off past the tower. And so that'll be about 6 to 7 seconds right there. Where you pass the tower at that point. And so it's going to be quite an amazing event to see there.
I have a question from Robert Turpin. Does the payload area being under vacuum weaken the integrity of the Starship?
So one of the kind of interesting things about this is there's going to be the slightest amount of pressure, but the real thing that they have here is that it's going to be decompressing as it's going up into higher elevations. And so it's not going to actually be quite a vacuum until it gets into space. And even then, it still has a little bit of CO2 that's being pumped inside the engine fairing covers. So right where the ship is at, and it goes into the inner stage as well, but it's just a small amount of CO2. So it's never exactly at a vacuum there, but it gets pretty close. But they have a lot of stringers and other structural reinforcements that holds up the entire ship as it is right now, with all of the propellants, which is about 12,000 or 1,200 metric tons of propellants, plus a vehicle itself that's about 100 tons, and any payloads. It could go up to about 100 or 150 metric tons of payload capacity. But it's able to hold all of that up just on that metal skirt, and it's not really pressurized. It's 1 bar differential at this point. But during liftoff, it does actually have a little bit of pressure, but not much. It's not really anything that's useful.
Question here from Sarah KB7. Why does NASA keep sending a WD-40 aircraft to spy on SpaceX flights? Well, actually, Sarah, it's a WB-57, and it used to be a bomber that's been converted to a reconnaissance aircraft, and it's under charter to SpaceX. It's not flying for NASA, it's flying for SpaceX. And there is also one out at Hawaii that we anticipate will be filming any re-entry potential.
Yeah,
That one we're not sure about, but we do know this one here is under charter from SpaceX.
yeah, and it will be Whiskey Bravo 57. So that's what you're looking for on the letters. But I love that WD-40. That's that's funny.
Well, she keeps wanting to chase that water away.
Yeah, good point.
Uh, Kenneth K. I couldn't believe what I heard just now. Is Booster 7 going to be destroyed? What about Starship 24?
Oh, they're both getting destroyed. That's the excitement about this is we are basically going to see a controlled splashdown of the booster about 19 to 20 miles offshore from where we currently are at Boca Chica in Starbase, Texas. They will basically send the Starship or the second stage, the Starship itself, all the way to Hawaii, where it'll basically be really like trying to resist burning up in the atmosphere, and hopefully it makes it all the way. But even then, when it gets to the point where you normally do the flip and burn, there's no propellants in that header tank for the methane side, and it's going to just do a belly flop right into the ocean. It's going to be the world's biggest belly flop with excitement of explosions and everything else. So we do have another part what we can go through right now actually to show this and to explain it. We've got Stephen from basically Spaceflight Now. Stephen, want to go through and talk a bit about our trajectory here today?
Yeah, can you hear me?
Yeah, we can hear you. And a quick note, the graphic on the screen is thanks to Dr. Marco Landbrook from Twitter. So here's the graphic here. So go ahead, Stephen.
Yeah, today we expect to see, if the weather and technical conditions permit, the Starship lift off and head roughly due east from Starbase out over the Gulf of Mexico. And it'll be performing a burn with the Super Heavy booster for about 2 minutes and 49 seconds. And that booster, you can probably see here in the hazard zones around Starbase and the Gulf of Mexico, will be attempting a controlled landing in the sea. It will not be returning to land on land. Those tests and demonstrations will come in the future. The Starship vehicle, if all goes according to plan, will light its 6 engines for a burn of about 6 or 7 minutes to reach a near orbital velocity. We're expecting the max speed to be somewhere between 16 and 17,000 miles an hour, just a little bit shy of the speed that you need to reach a stable orbit around the Earth. And then the Starship will coast around the world. It'll fly over through the Florida Straits, fly over the Caribbean, the Atlantic Ocean, the Indian Ocean, and finally, it'll be coasting at this point. The Starship vehicle will be unpowered, no propulsion, and will naturally re-enter the atmosphere over the Pacific Ocean, heading on a rough trajectory from the southwest to the northeast, and will impact north of Oahu if everything goes perfectly on today's flight. Of course, we've heard Elon Musk try to set low expectations for this mission. Everything would have to go truly perfectly for the Starship to actually make that impact or on target in Hawaii. We expect the max altitude, the peak altitude on this mission to be about 146 miles or about 235 kilometers. That's according to the FAA, which of course has reviewed all this trajectory information from SpaceX to issue their launch license.
What's the probability do you take that it will beat all mission objectives? That was the question earlier, and want to get your percentage on this. At it meeting all of the objectives here.
So all the way to an on-target splashdown of Starship near Hawaii, I would say 1 in 3 or 1 in 4 is just my gut.
All right, thank you, Stephen. And this is Stephen from Spaceflight Now. I would recommend also heading to their channel, giving them a subscribe, as well as watching their videos. They've got great content for every launch from Florida, and now they're here with us today live as well. So thank you for that, Stephen.
Yep.
I did
Thanks for
also
having me.
I did also want to jump in and let everybody know that we do have a weather station on Rover 2 that will be monitoring the temperature at liftoff. If we get it today, we're really curious to see what kind of ambient temperatures we get across the street from the launch pad. So we'll keep you updated as soon as we get that data in.
So again, this is this map that's on screen right now. One other thing to note is that there are numbers across the screen. Those should be the time marks for how long it takes to reach these objectives. So it's between about 85 and 90 minutes is what we should be seeing here today.
You know, Lab, I would love to know the temperatures on the launch pad that all of those cameras are going to have to deal with.
Yeah.
Melty.
Mauser sent me a message the other day with some documentation that was talking about the ambient temperature near the launch pad, and the surrounding area is supposed to get in upwards of 300 degrees Fahrenheit, and up to a third of a mile away, 200 degrees Fahrenheit, and up to a little over a half a mile away, it should reach up to about 90 degrees Fahrenheit. So the cameras that are the remote cameras that the media set up on the launch pad, I'm not. I have a feeling we're going to have some damage.
Gonna be a
Yeah.
GoPro graveyard.
I posted a tweet about that this morning or last night because, you know, after watching several of those static fires, you kind of get an idea of what's going to happen on the landing pad. And you know, one of the things that the phenomenon that happens, I would say, is that because of the way that the flame diverters are shaped on the legs, they're almost like wings on an aircraft. And so when the exhaust is passing by them, it actually curls around it, and so it creates a vortex, and it does it in several different directions. It does it in the direction that's coming towards the wetlands. It doesn't do it towards the tower because I think the tower kind of has its own effect on that on the exhaust flow, but definitely on the landing pad, it's almost like a horizontal vortex that passes over it, and I think it was a 14-engine static fire. I don't know if it happened during the 31, but it actually was strong enough to knock over the front gate at the entrance. So it's going to be really interesting to see what happens to everything that's on the landing pad.
I do have some more documentation from the EIS study that our buddy Tommy Sines just brought up for me. The exhaust and heat plumes they're saying that the heat plume generated from the launches would travel away from launch pad with temperatures of 2,120 degrees Fahrenheit, approximately a third of a mile from the launch pad, and temperatures reaching ambient temperatures of 900 degrees Fahrenheit, 0.6 miles from the launch pad. The heat plume may cause some alterations to the plant community and could lead to vegetation changes. So, yeah, that is a lot more than the documentation that I read the other day.
All right, we do have confirmation that we have a couple of things going on here. That the weather is going to be still an issue for this launch here today, and we also do have SpaceX going live, and we'll be jumping in and out of their commentary as well. A lot of the information they'll be covering here is going to be some of the same stuff that we've heard on Monday. So we'd like to be able to go through and still answer a lot of questions. So we will, whenever Innsbrucker comes on, we'll basically cut directly to him here.
Phila, we got some super chats you want to share?
Yes, I do. I have Matt Miller for $10 US. I have the one and only with $5 euro. Jill Clegg, $20 US. Thanks, Lab Team, for all your work, and go Starship. Tom Horn for 100 Norwegian krona. Come on, baby, light my fire. Daniel R., $5 US. Why don't they attempt to land the booster on the launch pad? Wouldn't they need to test the landing as well? And Astro CJ 42, $20 US. How long do you think it will take S-24 to swim back to land?
Well, to answer Daniela's question, Zach, why don't you answer that question? Because that, again, stage 0 kind of is your wheelhouse.
Sorry, can you repeat that question?
Why don't they attempt to land the booster on the launch pad? Wouldn't they need to test the landing as well?
I'm assuming they mean like if actually attempt to catch the booster this time.
Yes.
Well, as fun as that would be, I think the important thing to do would definitely be to make sure that they're able to duplicate what they're going to have to do on the landing pad, or sorry, on the what do we call it? I keep wanting to call it landing pad, but it's really not. But essentially, they need to be able to duplicate that catch maneuver out over water. So I'm assuming that using the booster's computers and probably like some external observation cameras or something like that, they'll be monitoring it to make sure that it's able to hold position long enough as it would have to do when the chopsticks are going to catch it. So, initially a few months ago, we were thinking that SpaceX may actually try to attempt to catch it on the first attempt. It was kind of seeming that way with the additional catching hardware that they were installing on the chopsticks, but I think for good reason they're going to collect the proper data first before they actually do that attempt. However, if they did try to do it on the first time, I actually, wouldn't be surprised if they pulled it off. But unfortunately, we're not going to get to see that today.
Yeah, I'm anticipating.
We do have a tweet that just came out from Elon saying that Starship is on track for launch.
I'm anticipating that potentially we might see the arms function in a method as a test as it was catching the ship, if the ship was coming down in location versus 20 miles offshore, that as the ship descends, the arms might close in and simulate a capture. That's a scroll on my part, but I'd like to see that.
Oh, I'd love to see that too. It gives us more visuals on this end as well. And I'm hoping we get to see a little bit of that booster reentry, but that fog is really not making things easy here.
I have one more super chat from Luke Zhang, $2.99 Australian. Will S-25 be launched after the revised review?
I do not believe that Ship 25 has a chance at this point. They've basically said that Ship 26 and 27, which have no heat shield tiles or recovery systems, would basically be the ones up next based off their documentation. Their documentation basically said the next two launches after Ship 24 will have no recovery hardware, which does imply 26 and 27. So we're pretty certain that 25 is basically the twin of 24, and that they do tend to skip the technology. That what they would like to do is full electric TVC, I believe, for Booster 9 and Ship 26. So that's the direction I believe they're headed, away from the hydraulic thrust vector control. Sorry, that's the TVC part that we've seen them go through and use at McGregor, for instance.
Yeah, most likely 25 is destined for the smelter's yard.
And so what other questions do we have here while things are going on?
Well, first, I'm kind of disappointed, Thomas. We have quite a few viewers, and I only have 1.9 thousand likes. Come on, guys, let's do a better job on the likes. Hit that button, please. I have a question here from Fran X. When you believe SpaceX released the clamps for the liftoff on the engines, when will the clamps lift on the release after engine ignition? 5 seconds or less?
So it's going to be like 3 seconds or so. It's going to be starting up all of the engines for the booster, then releasing there. The interesting part is with the ship, it will basically be in a spin. So think of how they've basically released the Starlink satellites. They treat them like a deck of cards that they're spinning the whole thing, and they basically separate from each other. And because it's in 0G, they just continue on their own direction. They're going to do the same thing with the booster and ship here.
So I actually have some interesting information on that. I'm not 100% sure if it's public or not, but from what I've been told, the clamp release actually occurs 15 minutes prior to launch.
For the booster itself?
Yes.
That would be interesting.
Yeah, well, I mean, it kind of makes sense in a way. With how heavy the vehicle is, like even right now, I mean, we're about 30 minutes out for launch, and the vehicle is so heavy that it would take a very, very strong wind force to knock that over. it's what 5,000 tons. So it kind of does make sense that you would want to release them early and make sure that everything's good to go with those. But it's also kind of scary when I heard that. I'm like, wow, 15 minutes early. That's pretty impressive.
Yeah. The thing that doesn't make sense is that when it releases, it would need to be able to release. I would suspect when it has verified the engines are lighting and they're in good order. But they do have 33, so there is redundancy. So 15 minutes, it isn't disqualified on that. That's an interesting thought.
Andy Adler had a question. Do they super chill with the helium bubbler? If so, where?
Well, Zach, do you want to answer that one as well?
The wind was a bit loud right there. I wasn't able to.
Yeah. So where do they use the helium bubble system? So they've got a helium bubbler. Where do they use that?
I do not know the answer to that one.
Okay.
I think it's used in the Raptor engines, but I have heard that it's also used in the actual propellant tanks, but I'm not 100% sure on that one. You may be able to answer that a little better.
Yeah. So they do have the a helium bubbler. It's going to be inside the booster, and I believe they do as well at the upper stage, and it basically is going to be in the main tanks. So it takes a lot of the heat away as it bubbles up. And so it is going to be vented off afterwards at the top of the booster, on the top of those vents. They'll be basically removing all the heat. But for now, for the last 30 minutes, we're going to go ahead and switch over to the SpaceX commentary here. So go ahead and keep asking questions, and we'll answer them afterwards.
Be the first of many as we work towards transitioning Starship from a developmental into an operational program. And the primary objective today is to gather as much data as we can around the fully integrated vehicle. Now, while we have flown the Starship spacecraft in the past, it is going to be the first attempt of Super Heavy and the first opportunity for us to validate how the two vehicles operate together.
We are so excited for this. The purposes for today's flight, we will consider any data received that helps inform and improve future builds of Starship as a success. From a milestone standpoint, our main goal is to clear the pad. Every milestone beyond that is a bonus. The further we fly, the more data we can collect.
Now, if it does all go well, then we'll expect the Super Heavy to light up its 33 Raptor engines at the base of the vehicle and lift off, clear the pad away down from Starbase in Starbase, Texas, and then it'll go into ascent. About 3 minutes into its ascent, we're going to expect to see Super Heavy separate from the Starship. It'll perform a flip maneuver, and then it'll execute a boost back burn, and we're going to be targeting a hard landing in the Gulf of Mexico.
And while that's happening, we hope to see Starship's 6 second stage engines ignite and watch as Starship coasts for about an hour at altitudes ranging between 150 and 250 kilometers before re-entering Earth's atmosphere and make its own hard landing in the Pacific Ocean about 250-ish kilometers offshore. Now, we are not really expecting many camera views after separation. That is to say, if we even make it that far. But we do promise that whatever views we do have, we will bring them to you live.
Yep. We have a couple of ground stations along the way. So if we are able to get good telemetry, assuming we make it that far into the ascent, then of course those will be available on the stream. And also worth mentioning today, like the whole just getting the vehicle off the pad is a complex endeavor. We are going to be trying to reduce complexity by attempting those hard water landings instead of trying a normal landing like you're used to on Falcon 9.
Exactly. We are not attempting to recover these vehicles. So yeah, hard landings in store for both.
Now, in a little bit, we'll take a closer look at the vehicle and the launch pad. But first, the teams have been doing a tremendous amount of work over the last few months. In fact, there's a great shot of our Hawthorne team up here bright and early to watch the launch. Teams have been prepping really for the last few days, especially to try to get into today's launch attempt.
And here you can see a live view of the South Padre Amphitheater where both SpaceX employees, friends and family, and members of the public are gathering to watch Starship lift off. And we can see the crowds are gathering there as well. And of course, we want to give a shout out to the SpaceX team. You see them there on screen, members of our our Star Command Center. That is our Starbase Launch Control Center.
Yep, those are the operators today who are going to be reviewing all the data and, of course, giving us the go, no-go poll, checking the status to try to get in today's launch attempt just around 27 minutes from now.
And one thing I do want to mention, I misspoke. It's not the South Padre Amphitheater, it's the Cameron County Amphitheater.
Now, the entire Starship structure on your screen is made from stainless steel. When it's stacked, it stands about 120 meters tall. It's about 9 meters around. And we have this awesome video that shows you just how big that is. You can see one of our technicians there doing some final prep work in advance of today's test. And man, there's the 120-meter monster.
The person just keeps getting smaller and smaller. Now, just like Falcon 9, Starship has 2 stages, which we'll talk more about those in a minute. In addition to those 2 stages, Starship actually has a 3rd stage, which we call Stage 0. It consists of all the launch pad infrastructure built around the rocket, as you can see there on your screen, and it's truly an engineering feat in its own right.
Yeah, we've got a great shot there of the various different components of it, the pad, the infrastructure, all that is required to get into filling the tanks. Now, let's talk about the Super Heavy. Its name says everything. It's super, it's heavy, it's super heavy. When it's operational, it'll be responsible for providing the power to escape that mighty gravitational pull of Earth that we've got here and take Starship into orbit.
The booster itself stands about 70 meters tall and is roughly the same height as a fully integrated Falcon 9, which is just so crazy to me. But this Super Heavy booster has a diameter roughly 2.5 times that of Falcon 9, and with 33 much larger engines. We have a beautiful view here. This is one of my favorite views that we're going to get today. Those are our 33 Raptor engines at the base of the Super Heavy booster.
Yep, and you can see they're in a couple of different rings here. So we've got the outer ring of 20 static engines. They're going to be providing a huge amount of thrust today to lift off the entire stack. But then we've got the 13 gimbaling engines in the middle, and they're going to be providing the tilt maneuvers and also helping to reorient the booster as it comes back later in today's flight.
Yeah, and when we say gimbal, it's basically tilting or almost wiggling the engines a few degrees in either direction to allow the booster to steer itself, just as you said, Shiva.
And we'll get some great shots later of actually a wiggle test that we perform ahead of liftoff, just to make sure that all of those engines are able to control their full range of control authority.
One thing to note, those Raptor engines are completely designed and manufactured in-house. They are, as many of you know that have been following along, they are a reusable methane oxygen staged combustion type engine. So it's a lot of words there. And ultimately, that staged combustion means that we combust the propellant in stages that we kind of pre-combust them in a pre-burner, and by doing so it allows the engine to be more efficient, i.e. more powerful.
Yeah. Now, like Falcon 9, the Super Heavy has 4 grid fins to assist with orienting itself in its return back to Earth. We got a shot of them there beneath the Starship's aft flaps. Now, as we talked about earlier, Super Heavy is not going to be attempting a land landing today, but with this flight test, we're still trying to get as much data as we can. We're focusing on the fundamental systems and operations, so that's the liftoff portion, but we are going to try to get some data on how the fins work for that water landing that Super Heavy is going to be making after ascent.
I love that great view of the fins there. Now, Starship, or the spacecraft, is the 2nd stage, and it makes up the top portion of the vehicle. It's designed for carrying passengers and cargo to Earth orbit and beyond. It stands about 50 meters tall, which is a little taller than the Statue of Liberty. It's comprised of 6 Raptor engines, 3 sea level and 3 vacuum engines, which are optimized to operate in the vacuum of space. And they provide a maximum of 258,000 tons of thrust in vacuum. Spacecraft is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude, which you can see those 2 forward flaps there on your screen now. So they help control the vehicle's attitude during atmospheric flight and enable precise landing at the intended location. Now, one thing we got to mention, the heat shields. They are iconic. Starship is wrapped in a heat shield, which is composed of 18,000 hexagonal ceramic tiles designed to insulate the vehicle during that atmospheric entry. And that's really important because the temperatures can be as high as 2,600 degrees Fahrenheit. The hex-shaped tiles, like the ones that Shiva and I have, roughly make up about 2/3 of the vehicle. We can see that we have some different shapes. Mine is slightly curved. As you can imagine, it sits on the curved portions of the Starship vehicle.
Now, the one that I've got is a hexagonal tile that's more flat, and it's really used for the flatter structures on the vehicle. And we need a heat shield because when you're coming back in from re-entry, we're going supersonic, we're compressing all the air ahead of us. That ends up causing a lot of heating along the surface, and without a heat shield, that would go straight into the structure.
Yeah, one thing that's amazing to me, especially when I first picked up one of these heat shield tiles, is that they're so light. They almost feel like they're made out of foam. They're that light, and they kind of sound like it too. And one thing that we do want to mention, in order to reject the maximum amount of heat during that entry, like Shiva was just saying, they're black, and that's because black helps reject that heat that is building up on the exterior of the heat shield.
Now, Starship is designed for vertical takeoff and landing as opposed to taking off and landing like an airplane, and that's because that's really important because we don't have runways on the moon or Mars. Fortunately, at those destinations, the gravity is not as high as it is here on Earth. On Mars, the gravity is just 1/3 of what it is here on Earth, and on the moon, it's just a sixth. So in both of those cases, Starship, with just its engines, can take off without needing the super heavy booster like we do need here on planet Earth.
Now, for today's test, Starship does not have its landing legs attached because, like we said before, it won't be returning anywhere. Starship is expected to make a very hard ocean landing, which, if we even make it that far and manage to get any views, it will certainly make for a very exciting end to today's test. At this point in time, we are 20 minutes or just over 20 minutes from liftoff. Let's check in with John Innsbrucker for a status update. Hey, John, how's it looking?
Thanks, Kate. I'm John Innsbrucker, Principal Integration Engineer here at SpaceX. We're currently loading propellant from the ground system into both the first and second stages. Now, both vehicles use the same two propellants. That commonality helps build the reliability. And the fuel today is liquid methane, and that's at a temperature of just over 100 kelvins. That's about minus 272 degrees below zero on the Fahrenheit scale. Now, liquid methane is a different fuel from Falcon 9. That booster uses RP1 kerosene. However, our oxidizer is liquid oxygen, and that's the same as Falcon 9. Because there is no oxygen in space to support combustion, we have to bring our own. Now, leading up to where we are right now, we had a go-no-go poll. That was conducted just after T-minus 2 hours. And once the team gave their goes, we started loading propellants onto the booster at T-minus 1 hour and 39 minutes. At T-minus 1 hour and 22 minutes, we began propellant loading of the ship. The second stage you can see on your screen right there. Now, propellant loading of the Starship's second stage main tanks completed at about the T-minus 27-minute mark, at which time we then began loading the two header tanks in the nose of the second stage. Now, at T-minus 3 minutes, when the first stage super heavy propellant loading completes, that means we'll have all the propellant on the rocket, and the vehicle will be fully loaded with over 10 million pounds of propellant. Now, right now, at T-minus 19 minutes and counting from liftoff, the weather and winds are looking good. We have been watching the ground level winds. They're at 18 miles an hour. As the morning continues, they will increase, but that is below our limits right now. We're also looking at upper altitude winds. We're waiting for one more balloon, but we believe that we're going to be go. On the launch vehicle itself, the teams, the good news, they're not working any issues right now. But if for some reason we do not make our test flight today, if we have to hold, we have a backup launch window. However, we're not sure when it would be. It could be 24 or 48 hours after today. It'll depend on how far we get into the countdown. But right now, heading for a T0 at 8:28 Central, 13:28 Universal Time. Kate, everything is looking good.
Awesome news. Now, in order to make life multiplanetary, we need a fully reusable vehicle that's capable of carrying a huge amount of cargo and a lot of people to orbit and have a pretty quick turnaround. The idea is to effectively reuse launch vehicles just like airplanes.
Yeah, imagine if you had to wait for a new airplane to be constructed every time you wanted to fly. You'd rarely go anywhere, and for most of us, it would be completely unaffordable. In order for us to get to Mars and back with lots of people, lots of cargo, multiple times, reusability really is a must.
In advance of our first missions to Mars, Starship will execute a number of missions with both cargo and people, starting with Earth orbit and eventually expanding to the moon and beyond.
Now, in the near term and a bit closer to home, Starship will also be critical to other programs. Once fully operational, it'll deliver the full size and upgraded version of our Starlink satellites. And that's super exciting because our next generation satellites represent a step forward in Starlink's capabilities and will allow us to connect millions of more people around the world with high speed internet to watch launch webcasts.
Such an exciting future ahead of us. But first, let's talk a little about how we got to where we are today.
Now, Starship's testing ramped up in July of 2019 with our Starhopper prototype, sort of a short version of the Starship that we see today. There's a great photo of it. It was just over 18 meters tall. It had a single Raptor engine, and we had it to test fly and perform low-level altitude maneuvers and attempt landing. The initial test flight, or hop, reached about 20 meters in altitude. That was followed by the one that you've got on your screen here. This was our 150-meter altitude hop. We went up, took a little jaunt away, about 100 meters or so away from the launch pad, used that Raptor engine to fly and actually land. And actually, this hopper is actually down at Starbase now.
Yeah, I love this shot. It's just so fun to see it fly. After a series of 150-meter hop tests with earlier prototypes, the Starship program saw a major breakthrough during a test flight of the vehicle known as serial number 8, or SN8. You can see it there on your screen now. In December 2020, SN8 demonstrated a first-of-its-kind controlled aerodynamic descent and landing flip maneuver. 2 words, belly flop. The SN8 prototype rose to an altitude of 12.5 kilometers or 7.8 miles and conducted a belly flop maneuver, which you see there, during its descent. While it didn't stick the landing, the test was a major milestone in the development of Starship. In fact, we should be able to see that unfortunately failed landing. Boom. It was fun to watch, though.
Rapid unscheduled disassembly, but learned a lot of data. Now, the testing continued on to prototype serial number 9. It took a 10-kilometer flight. That's about 6.2 miles up. In February of 2021, we had a nominal ascent. We executed the engine cutoffs once we got to the top of the altitude window. We did that belly flop maneuver, which is so much more fun to say than controlled descent, aerodynamic maneuver. That was all stable, but unfortunately, we had a dramatic end on this flight as well. We had a failure on one of the engines that resulted in another pretty large fireball. But what was really cool about both of those flights was how much we learned just between serial numbers 8 and 9 and how quickly we were able to achieve our primary objectives in those 2 flights. In addition to that, we got so much data that demonstrated control of the vehicle in that subsonic regime.
Ultimately, we performed 9 Starship high-altitude test flights in total. And then, as you see on your screen there, in May of 2021, SN15 launched from Starbase, reached an altitude of about 10 kilometers, performed a number of maneuvers, and safely returned to the launch site. This was the first Starship prototype to fly, control its descent, safely land, and be recovered in one piece.
And people were cheering like crazy
I was
after
one of
that
them.
test flight. Now, having achieved those successes in our suborbital campaign, one of the next big challenges is for the upper stage when it comes to reusability and surviving the hypersonic, really high heating phase of entry. Combined with the later ability to refill Starship's tank with propellants, the fuel and oxygen, while we're on orbit, that will enable us to have a fully reusable transportation system that's designed to carry both crew and cargo on long-duration missions, interplanetary flights, and will help humanity get to the moon, travel to Mars, and beyond in our solar system.
This is all just basically our path of progress, basically an iteration on each vehicle. And that iterative process is a core part of how we work here at SpaceX. We like to test early and often, publicly as well in our case. And that's both for hardware and software. And while it doesn't always go as expected, we learn so much from it and it informs our next attempt.
Yeah, we learn a lot from actually putting the vehicle through flight-like tests. Even the test on Monday gave us an opportunity to learn more about the vehicle into today's launch attempt. And so far, things are looking really good. Now, we are continuing into our countdown. We're about T-minus 12 minutes to go. I think it's a perfect time for another check-in with John Insprecher. How's it going, John?
Well, Shiva, the good news is that the nets are quiet. The teams are currently working. No significant launch vehicle issues. You can see the T clock there on your screen, T-minus 12 minutes, 10 seconds, and counting. Propellant loading is continuing on both the Super Heavy and the ship stages. You can see the graphic on the left-hand side of the screen. Most recently, we began loading liquid oxygen and liquid methane fuel into the header tanks on Starship. Those are two small tanks just underneath the nose of the second stage. Now that started at T-minus 27 minutes. That'll be wrapping up at about T-minus 9 minutes. Now the Starship second stage main fuel and LOX tanks are loaded for flight right now. The Super Heavy first stage booster propellant loading is continuing, and that'll go till about T-minus 3 minutes. We're underway with engine chill as we get ready for T0, and we're also configuring the launch pad for liftoff. The booster hold downs have been unlatched. They'll be ready to retract at liftoff. And the second stage quick disconnect is beginning its configuration for release. The methane and liquid oxygen propellants currently going to the second stage go through that quick disconnect. That's that arm that reaches out from the tower to the base of the second stage. The SpaceX team continues to check in with the Coast Guard. Good news is we've not heard any reports of boats in the safety perimeter as the launch vehicle heads out over the Gulf of Mexico. So right now, T-minus 10 minutes, 40 seconds, and counting. Everything continues to go well for an on-time launch.
Now, today's test flight is taking place out of our Starbase facility in South Texas, and that test site has gone through a huge amount of development over the last couple of years.
One thing I want to point out, this is a great view from our drone. Not only can we see the pad, but in the fog, kind of in the distance, in the background and to the left of the pad, you can actually see our production facility, which is the other part of Starbase in addition to the launch pad.
Of course, as part of rapidly iterating with our test program, we're also rapidly iterating on our production system to produce Starships and Super Heavies. Last year, the Starbase team produced 4 Starship Super Heavy boosters and 5 Starships, along with their 200th Raptor 2 engine, and they're only scaling up from there, Kate.
Yeah, it's incredible to think that for 2023, production has 5 boosters and 8 Starships going. So it's incredible. And it's important to have that system fill in basically the manufacturing line so that we have product ready to go as soon as we're done with this test.
Yeah, exactly. And ultimately, I mean, we talked about how Starship is an order of magnitude more payload to orbit. But if you're going to go set up a base on the moon or Mars, you're going to need thousands of metric tons of propellants. And so you're going to need a fleet of vehicles that's capable of doing that.
Yeah, one thing to note, Starbase directly employs more than 1,800 employees. It's the largest employer in the area, in fact. And we're very thankful to Cameron County for being so supportive. This is a view from the Cameron County Amphitheater. And there's a crowd there, and you could tell by the energy here in Hawthorne as well that everyone's getting really exciting. I feel my own heart rate going up and up.
I know. It must be really, really exciting to go see this. And I mean, just the sheer amount of power on Starship, you're going to feel it down there when this thing lifts off from the pad. We've actually got a great shot here of the natural surroundings around the pad. Oddly enough, most of the pads end up being around sort of wild locations like this. But coming up on T-minus 8 minutes, I think it's another good time for check-in with John.
Thank you, Shiva. T-minus just over 8 minutes to the first test flight of Starship. Currently, we are pressurizing second stage. We are also closing out liquid oxygen and fuel header loads on the second stage. We're also getting ready for propellant load tank pressurization on the first stage. In fact, we are just now closing out header tank load on the second stage. Now with the header tanks loaded and closed out, that means we're down to just the first stage to finish loading. That'll finish about T-minus 3 minutes. And at that point, when both stages are loaded, we will have the 10 million pounds of liquid propellant on board. Now in the next few minutes, the guidance system will begin its final alignment for flight during a quiet period when the rocket's not doing anything. The automated flight termination system will be armed, and a final TVC checkout will be performed. Those are the engine wiggles, and hopefully we'll be able to see that with the cameras underneath the vehicle and maybe even the second stage engines. And there's a view looking underneath the Super Heavy first stage with the 33 Raptor engines. Now, a reminder as we continue counting down, if we do need to hold, the point where we hold the clock would be at T-minus 40 seconds. We can pause there. Typically in the past, if we need a little bit more time to finish final checkouts or do some pressurization of the onboard storage tanks, that's where we would hold. But currently, we're not hearing a need to hold, so at 6 minutes, 27 seconds, everything looks good. And of course, Kate Shiva, as we get close, we're going to get into the engine ignition sequence of 33 Raptors, and that's going to be something new for everybody.
I cannot wait for that moment. So for those of you that are familiar with how we launch Falcon 9 rockets, you probably know that we light all 9 of those first stage Merlin 1D engines all at once. It's pretty different than what we do, or what we're attempting to do today. We're actually going to be igniting those 33 engines in banks or clusters, and that sequence starts at T-minus 6 seconds.
Yeah, and the ignition sequence is a little bit different, both in terms of the timing and also the ignition method. So on Falcon 9, we use a chemical called T-Tab. It's a pyrophoric material, so that means when you mix the two together, it produces a flame that kicks off that green characteristic spark on Falcon 9 missions. But actually on Starship, we use electrical ignition systems. Many of those are integrated on the ground system here. And the electrical ignition, we start lighting the banks at T-minus 6 seconds, and then over the next 4 seconds, the 3 sets of banks will ignite and eventually bring the booster up to a thrust to weight greater than 1 and hopefully ascent.
Super exciting. Like we said, pretty different from our Falcon 9 launches, and so this will be the first time that any of us have gotten to see this type of integrated test flight with both the Starship and the Super Heavy booster.
Everyone cheering as we get into T-minus 5 minutes.
We want to remind everyone that success today is anything.
Yeah, it looks fun down there. I kind of want to go join them.
For today, success is anything that we learn that helps improve the future builds of Starship. If we lift off and clear the pad, we're calling that a win.
A great shot of the pad there. A great shot of the quick disconnect on the second stage. You can see the frost line on the booster where that methane is fully topped up. I think we're just coming up on the last few minutes here of propellant fill on the booster. Now that quick disconnect is going to separate away as we actually get into the ignition sequence, but it's providing electrical connections now and also providing the propellants that we're loading into the vehicle.
Yeah. We're just now under 4 minutes until liftoff of the Starship flight test. We've been following along for what honestly seems like days and days now, but really it kind of comes down to years. It has been a long time to get to where we are today. Now, fast forwarding a little bit, we have the opportunity to hold, if necessary, at 40 seconds, and we are able to hold there for about 15 minutes or up to 15 minutes and still be able to lift off.
Yeah, and that's a little bit different from Falcon for the propellant sequence on Falcon that we don't have the opportunity to hold. So that's a cool new capability on Starship.
Yep. Right now, T-minus 3 minutes, 10 seconds and counting. We got some great views from the drone. It's nice that the fog is slowly lifting. We get some of the blue skies, hopefully good views. What we're waiting for right now is closeout of propellant loading on the first stage. That should be wrapping up here shortly. In fact, it looks like fuel fill and drain valves are coming closed. That means first stage is fully loaded, second stage fully loaded, and that 10 million pounds of propellant on board the Starship launch vehicle.
I want to take a quick moment to say that the crowd energy here is electric. I feel like it's Falcon Heavy test demo all over again.
And hopefully you'll hear us as we get into the plus count. But right now, next activity is coming up. The flight termination system arms at T-minus 2 minutes. Thrust vector control checkouts at T-minus 2 minutes. And then after that, major activity will be the T-minus 40-second gate. There's a view looking up at the 33 Raptor engines. There are 20 engines in a circle on the outside, and as Shiva said earlier, 13 engines on the center. Those are the ones that gimbal and steer the vehicle.
I don't think I've ever seen someone so excited for TBC wiggles.
Love this view. These are the 33 Raptor engines at the base of the Super Heavy booster. I think we can see those wiggles now.
We're currently inside 90 seconds. Next major activity, T-minus 40 seconds. That is a gate, a decision point. We're waiting. Possibility the propulsion team may need a few minutes. Flight termination system is armed for flight. We're getting ready for T-minus 1 minute and counting. No, T-minus 1 minute and counting. Next, we'll see as we get past T-minus 40 seconds for final checks of the vehicle. Okay, you can see the clock is recycled. Flight director has called a hold. We are recycling. For the moment, we'll see where they move the clock back to. They could hold at T-minus 40 seconds. They could go to an earlier point. Give us a minute to listen into the nets, and we'll see if we can get you more information to share. John Innsbrucker again here at the Hawthorne webcast desk. We're holding at T-minus 40 seconds. What we've heard so far is we have a couple of issues we're working. One is the booster tank pressurization. Final pressurization was just a little bit long. That's not unusual. We've held at T-minus 40 seconds before to pressurize. That appears to have been resolved. At the same time on the second stage, they're working some final purging. We should know very shortly if that is cleared and if we'll continue the countdown.
Everyone, especially that person, is excited to keep going. Like John said, we should know shortly if we are able to continue. But as we mentioned before, we are able to hold up to 15 minutes and still be able to lift off today.
Yeah, on Falcon 9, it's a little bit different. Once we start propellant loading, we pretty much have to go at the targeted time. Otherwise, the propellants can warm up and we may not have the performance for that particular mission profile. It's a little bit different on Starship.
Folks, if I can interrupt.
Yeah.
It looks like they're clearing all the flags, and we're going to release at T-minus 40 seconds.
That is amazing news.
Amazing.
Team working quickly through their issues on first and second stages.
And I'm sure all of the rehearsals and simulations that they've been doing have prepared them to evaluate this data quickly to try to get us in for today's launch attempt.
For those of you just joining, we have a brief hold at the T-minus 40 second mark. The team is resolving one issue with the bleed purge on the stage 2 Raptors. Like John just said, the teams are quickly working that, and it looks like the flags are being cleared as we speak. So we should be able to resume the launch countdown any moment now.
And it's worth noting on Starship that once we resume the countdown, it restarts from the 40-second period, and then we keep going unless another condition pops up. So stick around because Starship could be going here real soon.
Don't walk away, that's for sure. Amazing views here coming to us from Starbase, Texas.
Cheering to call the start again.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 3, Raptor chamber pressure is nominal.
T-plus 33 seconds into the test flight of the inaugural Starship vehicle. Tower cleared, we're into pitch over. Propulsion reports first stage engines nominal. What a sight from the ground cameras at Starbase. We're flying at twice the thrust of the Saturn V heading to space.
Acquisition of signal, surface proceed.
We're throttled down and throttled back up. Going through the period of maximum aerodynamic pressure. As the velocity increases, the density of the atmosphere is decreasing.
Max Q.
Lessening stress on the vehicle. The call out, max Q now. Continuing to watch the first stage as we head downrange. A 100 seconds into flight. Our next major activity is going to be shutdown of the first stage. Houston Tracking Station now acquiring the vehicle. With shutdown, we will get separation of Starship and Superheavy and ignition of the Starship engines. When Starship separates, we light up 6 engines in a staggered sequence, And if all goes well, those 6 engines will burn for almost 6.5 minutes. Onboard view from Starship. And there's views of the Raptor engines on the second stage as we prepare for stage separation. Now, after stage separation, the first stage will flip and begin a boost back maneuver for landing in the Gulf. Continuing to fly, 2 minutes 40 seconds. Let's get ready for main engine cutoff.
Booster engine cutoff.
Beginning to flip for stage separation.
As of right now, we are awaiting stage separation, where Starship should separate from the Super Heavy booster.
Yeah, Kate, right now it looks like we saw the start of the flip, but obviously we're seeing from the ground cameras the entire Starship stack continuing to rotate. We should have had separation by now. Obviously, this is does not appear to be a nominal situation.
Yeah, it does appear to be spinning, but I do want to remind everyone that everything after clearing the tower was icing on the cake. And there, as you saw, as we promised, an exciting end to the Starship inaugural integrated test flight.
Absolutely pumped to clear the pad and make it this far into the test flight, the first integrated flight of the booster and the Starship vehicle.
Live view there of our control center at Starbase, which we refer to as Star Command. As we said before, obviously we wanted to make it all the way through, but to get this far, honestly, is amazing.
Well, if you're just joining us, Starship just experienced what we call a rapid unscheduled disassembly, or a RUD, during ascent. But now this was a development test. This is the first test flight of Starship, and the goal was to gather the data, and as we said, clear the pad and get ready to go again. So you never know exactly what's going to happen, but as we promised, excitement is guaranteed. And Starship gave us a rather spectacular end, but was truly an incredible test thus far.
Now, as we mentioned at the start of today's program, any and all the data that we collected during the test is going to help us with further development of Starship, and it's going to improve the vehicle's reliability as SpaceX seeks to make life multiplanetary. It's really worth noting that the flight path was designed to be over water and all the air and sea space. Along with that flight path and those surrounding areas were cleared in advance of the test. And of course, we're going to be coordinating with local authorities for the recovery operations.
But honestly, what an exciting morning. Oh my gosh. We had a successful liftoff from Starbase, Texas at 8:28 a.m. Central Time. We cleared the tower, which honestly was our only hope. We cleared the tower, and all the data that we collected all the way through all those Raptor, those 33, although I think we saw that 3 Raptor engines were out, but we got all that data, and we got so far as to hoping to see the Starship, the second stage, separate from the first stage, the Super Heavy booster. And unfortunately, we didn't make that happen, but that's okay. It was the first integrated launch, and honestly, today was amazing.
Absolutely incredible day. We made it through a number of those initial test objectives with getting booster ascent, getting all the way through the countdown, working some issues at the end. Like, totally really fantastic day.
Got through the gate at T-minus 40 seconds on the second try. everything released, the hold downs, quick disconnect arms, everything moves out of the way. And then we got the vehicle off of the pad, through max Q, all the way up to stage separation, even starting into the prep for stage sep. And then, as we say, a lot of excitement.
Yep. Honestly, my face has had a smile on it since liftoff, and now my face hurts. Now, since we don't have any insights on the cause of our rapid unscheduled disassembly at this point, we're going to end our webcast here. Teams will continue to review the data and work toward our next flight test. But before we go, a big congrats to the entire SpaceX team on an exciting first integrated flight test of Starship. And of course, a shout out to our viewers. We appreciate you joining us. And as always, we thank you for your interest in Starship, SpaceX, and your ongoing support. Till next time.
That was it? That's nothing, dude.
That
Okay,
was
cool. Good to
amazing.
know. Good to know.
We just saw the liftoff of Starship and Superheavy off of the orbital launch mount. I can't believe it. I'm just in shock. How about you, Phila Kid, Nate, Zach? Actually, Zach's muted.
Man, I tell you what, this was the coolest thing ever. We had a decimal meter here, and from 3.78 miles away, it was only about 95 decibels. It really wasn't that bad after all.
Wow,
Yeah.
that's not as high
And
as
as far as the loudness, it was, it's hard to gauge from 2 years ago, but it was loud. It was more of the vibration. You could feel it. I mean, the whole place here was vibrating from, as far as we're away 3.78 miles. My tripod was vibrating, and oh my goodness, awesome stuff, guys, awesome stuff.
Yeah, it looks like we got a little bit of fires at the pad there over towards the cameras, actually, of all things. I kind of see a couple other places of smoke. So hopefully their fire suppression system will be able to kick in and take care of some of that. But I do worry about the photographers' cameras out there.
Yeah, those photographer cameras, I'm anxious to see when we go back out there to pick them up. Our photographer, Nick D'Alessandro from Cape, is down here with us, and both of us went out to the pad yesterday afternoon to put some remote cams up. So hopefully we got some cool shots for y'all here later on this evening if they let us out tonight.
Yeah, they should be able to, as long as they get those fires out contained and everything situated there.
When you say fires at the cameras, at the remote camera sites, or which cameras?
There's a fire that looks like it's towards the cameras, but I'm seeing oh wow, we're going back through the flight here. So this is at liftoff of the booster and ship. We had large pieces of debris coming off of, looks like to be the pad, maybe the burn plates themselves, or potentially just other parts of the launch table. Maybe even the pieces that are around the engines themselves. Basically those covers, those plates that are around the skirt. During liftoff, we did see about 5 engines at least come off. I was expecting a RUD when I saw those flashes. Oh my gosh. Nate, Phila Kid, what are you guys' impressions, or especially Phila Kid here?
There was some yelling going on here, I'll tell you that.
My heart was like sinking as I saw these little explosions of the engines saying, we're giving up. We give up the ghost.
Yeah, you were looking at the bound side. I was going positive. It was lifting, and it looked like it was in good shape, and I was just thrilled to death with that. And I noticed you had picked out the engine failures right on.
Yeah, I was like trying to count them, at least 5 of them, maybe more. You can see there's at least 2 at the bottom, 1 at the top, and then 2 more at the top. So there's 5 there, 6 at least engines. Now I'm looking at it again.
Looks like 7.
Wow. Yeah, this is why I don't think it was able to get up as high. And then this was the failure point, was all those engines going out were giving off thrust or off nominal thrust. And they were trying to do a control of the spin. And 2 things were going on. They were not high enough because they didn't have enough engines. Lab, you're still beside yourself, aren't you?
And I'm watching this replay, man, and how you can see the engines, and as sucky as it was for those engines to pop out, it's so cool to see that view from directly under the skirt like that as it's up in the air and seeing them just turn off. Just unreal.
Yeah. Here's the good news about this.
Hey,
All of those engines
Thomas,
failing, they were protecting the engines from basically blowing up the entire vehicle or the other engines for the most part.
did
So
you
that's huge.
did you see the grid fin position on that last shot? That almost looks like it's off. This shot right here.
It looks like it's still on plane. It hasn't rotated yet, I don't think.
Well, I think it looks like it's in a rotated position. It just might be the camera angle and the lens that they're using.
Yeah, so they were up at 35 kilometers when they started rotating like this, and it really just dropped down in speed as they were spinning. So they were not even up that high. I was expecting them to be much higher. I was expecting up to about 100 kilometers. So that's the issue, is that they were trying to do this spin while they're still in the atmosphere. There is just too much resistance against the whole thing, and I think that's the death knell of the ship and booster there.
Though surprisingly, looking at this engine compartment shot, you don't see any stress happening on the outside of the booster and at the skin level. So it's not affecting the stress connection between the ship and the booster.
I think I think there is stresses going on there, but I don't think either the hold downs were released, or if they were, the stresses were so high on the hold downs that they could not release. Yeah, so you can look at the overlay at the bottom left, and it shows you at least those engines went out, but we were kind of counting a bit more than what was on the overlay. So the telemetry is not quite right, because we had at least 6 of those out, and I can only count 5 on the overlay. But when the FTS went off, I was expecting a large fireball. I was not expecting the smoke, or this basically release of the liquid oxygen and methane the way it did. Yeah, so that we're back on rover 1, and you can see the fire still progressing a little bit. But that's around, looks like actually test stand B and where about the cameras are at. So here we have a rover 2 view. Yeah, that's closer to the cameras, unfortunately. So I think some debris got picked up and thrown over there. I'm not sure exactly what. Well, the thing that was the worst idea is putting plastic bags on it. It protects the cameras. However, the heat will melt it. That's the real issue for plastic. You need to have basically a box to put your cameras in that is a good solid box. It protects your lens. Yeah, the tank farm is venting like crazy. Oh wow! Look at the right hand side of the fuel farm. There's a big dent on the looks like the oxygen tank.
Oh yeah. So just to give y'all an update on the ambient temperature, it didn't. I don't know if it just wasn't updating fast enough, but I only got a 10-degree difference, an immediate 10-degree difference. It jumped up from 73 to 83, right at 8:30.
Wow, yeah,
8:33.
That's going to be interesting. Is like, how long does it take to measure that? Because you might have an instantaneous heat up of the environment, like direct sunlight, for instance. It warms it up, but it's not warming up the air around it. Now you're measuring kind of the air now.
Yeah.
I'm trying to look for the dents here, but it's really warped. Wow, it's just right underneath that one fern on rover 2. You can see how it curves over to the left. Oh, they really do need that water-to-lose system to be active.
There really appeared to be a large chunk of something that flew off just as the ship started to leave and looked like it was heading that direction. When we relook at that, we'll be able to see that potentially.
Yeah, there's some speculation it was the HPU cover.
Ooh.
Did anybody happen to check out the VR cam yet?
That's a good one to check out because it's going to give you a full, complete view.
There are a lot of cameras on the ground at the VR camera site that previously were standing up and are leveled. The
Really?
tripods are all leveled. All the cones are spread all over the place.
Wow.
Yeah, I see a massive chunk of debris at T plus 10 seconds that heads over to that water tank. Luckily, it's a water tank now. And I think there's pressure waves and other things that are doing damage as well to those outside of those tanks. But those are about 6 to 8 millimeters of mild steel.
God.
But yeah, those flashes are never good.
And that flash looked like it was up in that on the side of the booster area.
But I do think one of the things that Elon mentioned, the CO2 being pumped into the engine compartment, so where the power heads are, that's a huge one. I think it saved them quite a bit, and as well as the shielding on all of those engines, preventing it from cascading even further.
You know what surprised me, Thomas, was the length of time it sat there before it moved. I was anticipating it to rise a little bit quicker, and then once it got going, it really fired.
Oh, dude, yeah. There's so much debris flying. I'm rewatching it right now. Oh my God, dude.
Yeah,
Whoo.
I kind of see a little bit of flames around the engines actually in flight. These orange glows just around the center engines. Something kind of is glowing in a way that it's hard to tell if it's the trail itself.
Oh, dude. I'm
But,
sorry.
wow.
I'm sorry. Is there any way that we can get a rewind live of the VR cam? There's so much debris. I mean, it looked like somebody threw a bucket of rocks onto the windshield of Rover 2.
I think
It
somebody
looks like,
did.
yeah, as a matter of fact, it looks like NSF's got some blown out windows.
Yeah, so we could see if we can make that happen here on our end. It'll take a little bit, but oh wow! I'm just looking at the current replay. We saw a lot of stuff inside the compartment of the two, and I think it may have just locked in that position as far as the view. But yeah, they were struggling to get that.
Sorry, look at this. Oh.
So let's see if we can get that VR cam view up here in just a little bit. And yeah, while we're doing that, we're going to watch these views from SpaceX because this is just fantastic. Like, it's spinning out of control at this point.
You know, if an HPU went out, that would explain why they lost attitude control as it went up.
Yeah, I suspect that the HPUs should be redundant, but it reduces the amount of force you can have on them. So they've already fixed the problem if that's the case on Booster 9. Here we go. Here's the VR cam view. Wow. Just a massive amount of smoke and debris coming along our way, and then just rocks. Oh wow!
Yeah, got the back window of the other car there.
It's not just the back window; it's the frame as well. Something massive hit it. We may have actually lost a window as well. I'm not sure. I just saw what looked to be rocks and glass, but it also could be from NSF's van as well. And yeah, all the cameras just got thrown off, except for one strong tripod. Wow.
That one over there on the right is holding strong.
Oh, there's one on the left too. So we got two strong tripods. And then we've got one on the very far right. It's been sandbagged. It looks like it's holding on. So we got three of them now. I'm just kind of double checking here.
And Bert and Ernie said, shit, we've seen this before.
Yeah, this is hurricane force winds here. With a little bit of a tornado to play as well. That's about what it looks like. Yeah, I only see, just two now. Just two survivors after all of that for cameras standing upright. But those are the safest cameras. But NSF's van, they got structural damage on the frame as well as the windows. I think a large chunk hit that.
Yeah, Epic Spaceflight has their hoot cam down there, and they left them in place, and they both got yeeted.
I would expect nothing less.
They both
He
got
was
yeeted.
probably one of the closest cam views,
Yeah.
but it's got a large berm in between, so I wouldn't normally expect to see that. And I'm also wondering when we'll see the fire suppression system really kick in here, and we're going to go ahead and look at Rover 2 now as well. Yeah, it's about 6 seconds, and I still haven't seen it move, and that's like that T-6 that we were talking about, or that SpaceX was talking about, that we were talking about in here as they were doing their stuff. Oh my gosh, that cloud just comes in, and
Wow.
Well, I mean, Thomas, this is very common for the NASA flights down to Cape also, because you've always, there's always somebody reporting if their camera got taken out by a rock or something.
yeah.
So this is not to be unexpected.
Yeah, the thing that it was kind of unexpected for me is for these photographers, many of them I've seen in the past will have a box they put their camera in that protects the camera from debris. It will usually have a glass front. The glass front usually gets broken, and then they'll have a sacrificial front on their lens, similar to like a polarized lens filter or something like that. But wow, looking at NSF's van, yeah, that is a massive cave in on the back there. I can't stop looking at it. So let's actually go ahead and bring up basically our super chats as well as our questions here, and we'll continue the conversation with you guys directly.
Okay, I got some super chats here from Keith Penny, £5 sterling. Go Starship. Do we know the current wind speed? Doesn't matter at this point, Keith, but thanks for the £5.
And yeah, and Phila, just so you know, we had a few of these that happened before the launch. So
I'm aware of that.
Yeah.
Yeah, that one's obvious there, but we'll keep going through. Thank you.
Art Reef, $5 US. What's the possibility to see this from St. Pete, Florida, or would be too high? I think we have an answer on that for now.
0%.
Paul Hardy, $19.99 US. Dedicating this lunch to Parker Hardy from Simpsonville, South Carolina. He's at school right now. Unfortunately, can't watch live, but I'm sure he will enjoy the videos. Greg Albright, $50 US. Thank you very much, Greg. Gary McD, $10 US. ACAD, £40 sterling. Thanks, Lab, Rusty Mods, and commentators. Countdown Jacks, €11. Go SpaceX, go. Thanks for all your coverage. Gary McD, another $10. We are all entertained. Dingbad, $10. Thanks to Nerdle for making this fun. You all rock. And of course, Lab for the great coverage. Gabriel Rhodes, $5 US. Watch the multiplex cam. The audio and video debris is incredible. Astro Van Tuckett, $25 US. Amazing footage, Lob Padre. Keep up the great coverage.
Wow, I'm just still
Thank you all,
just
man. Thank you
looking
all for
at
those donations. I am still breathing hard over here.
Right.
I'd be having a heart attack right now if I was you at this point, because my heart's still just pounding away, going, wow. And everybody's outpouring of donations and support right now is amazing.
Hey, Lab, did the roost rock as much as it did during 15, or is it comparable or similar?
It rocked significantly more. I don't know if it was as loud. I mean, it was at least as loud. Maybe I'm sure it was a little bit louder, but it rocked like you wouldn't believe. This whole place was shaking way more than it did for Starships. And again, we didn't our decibel meter here was only reading 95 decibels from less than 4 miles away. So, and what I guess the wind is kind of blowing to the northwest right now, it seems like. So the island may have gotten a little bit more louder than we got here.
Well, you are the closest person to that ship when it took off, so you were at the spot to be.
Whew. Yeah, I am just amazed by that. The Rover 2 and the VR cam. Oh my God, those were the coolest images. And I didn't see the windshield smash, but I did see NSF's vehicle there. Their windows, their side windows did get blown out. So I wouldn't be surprised if I have some type of broken windows there. And I think those broken windows are just from debris, not from the sound itself.
Yeah, there was a large chunk of debris that hit the NSF van that you could see happen, and it caves in the back of their van. So it is pretty bad there.
The rear A posts are bent.
Yeah. So I'm pretty sure concrete or steel just came flying in and took that out. And wow, we're seeing a really good view now of basically that fire. Oh, there's drones coming in as well. But there's basically the water tank that's empty, and the 2 water tanks that are there. They also seem to have both of those have massive dents in it, but luckily they're water tanks, nothing of an issue there. I was seeing something kind of interesting earlier with the far LOX tank on the far right. Dude. It seemed to be venting as well. But yeah, I've got at least 3 fires.
It appears the fires are out. I mean, at this point, all we're doing is seeing venting from the tank farm from the CH4 reclamation tank. That's the biggest plume there. And then Tankzilla is venting a little bit, and that's part of the reclamation.
I don't know what that one on the far right is, though. That is a bit different.
Well, that's isn't that the oxygen overpressure line over on that far right side? And then there's the CH4 chill down pond that's on the far right, to the right of the OLIT.
No, I think that doesn't look to be the LOX anything from what I understand. That would be near the one of the methane tanks, or just to the right of them. It's kind of hard to tell from this particular perspective. Do we still have a view from Raptor Roost lab that we can see from your direction? What this little bit of venting on the fuel farm is I think just to the left of the. Yeah, I can barely see it there, but it is to the left of the what we call the Pope stack. But it's this large pipe. That one is normal. It's just nitrogen. It's the one that's down to the left that is unexpected. I've never seen a vent from there before. So I do worry about that one. It may be venting off one of the tanks, which is very unusual.
Remember, we've never had a launch before either.
True. This is a lot of unprecedented things. There is debris that has gone around and hit a few things. So I'm just hoping it's just a control line or something that's venting off.
Thomas, we've missed the big picture here. We've talked about all the negative stuff. Let's talk about some positive stuff.
It didn't destroy the launch infrastructure. That's the big one.
We have seen the world's largest rocket ignite, take off, and fly in a controlled fashion for several miles before it lost control and had to be destroyed. This is a world's first, and great expectations have been met from SpaceX.
Yep, and you've turned OBS.
Thomas, remember, we're live. Are we live?
No, we're not. Okay, is it still going on the stream? Okay, so yeah, we just had a little hiccup there. But this was a huge success as far as that we passed the launch infrastructure. Stage 0, the fuel farm, everything there is still relatively intact. Concrete, yeah, it's going to be needed of some repairs, some metal here and there, but overall, it's a huge success. They were able to launch this vehicle beyond their current, capabilities of what where it was like suborbital hops. Now this one is the biggest rocket ever launched, but we didn't quite make it to all the achieved goals. So I'm gonna have to eat crow on the 50% there. I was on the wrong side of that 50% divide there.
Anyway, Thomas, let me jump to some super chats here while we have people on board.
Yep.
Matt Miller for $100. Great job today. Thank you, Matt. Steve Minot, 20 pounds sterling. Thanks. Animal, 20 US dollars. Windshield repair fund. Mark Gagne, $11 Canadian. Starships are ready to go. So when's the next launch? Thanks, La Padre, for all you do. Jim Mailer, $10 pound sterling. Well done, lab. Having excellent views. You rock. Jake Winlow, $19.99. Thanks for the great coverage. Bruno Espada, 25 pounds sterling. Buy some glue and tape. Rocket Profit, $19.99 US dollars. Fantastic launch. Jerry Heger, 200 Czech ZZK. Thanks for the coverage. Dorm Wharf, $5 US. They need water deluge. Bruno Brito, 2 pounds sterling. Rivercam 2 and Lab Padre. You can see the camera massacre. Stumpy 001, 20 US dollars. That was awesome. I agree with you, Stumpy. I was screaming with you. Teacher in Space, 10 pounds sterling. How far is Rover 2 cam from the launch site?
Oh, so that I have to go through and measure again real quick. But okay. The views today have just been incredible from SpaceX, from each of the cameras we've gone through. So everything is just there's still a lot of motion in play, especially at the launch site, but still looks pretty stable. Just interesting new developments as far as different venting that I've never seen before, but it's always interesting. Do we have some more questions that we can go through here, Phila Kid?
I do.
Going along?
I do, and I got a couple super chats, so I'll hit those first, then we'll go to questions. John Hochever, $10 US. ULA has no failures. How impressive. Tom Horn, NOK, or 100 NOK, Norwegian krona. Valium. We need to slow down a little, Tom. You're correct. Let's go to some questions here. Some of these are from before the launch. Kenneth K, is it correct you said the Booster 7 is going to be destroyed? What about Starship 24?
That was a question before the launch, and both are destroyed at this point.
Yep. Why are SpaceX not attempting any sort of soft landing with the booster or the Starship itself?
Well, at this point, they had to activate the FTS during the launch because they seemed to be having off-nominal thrust. That was also, they were not given enough altitude in order to get outside of the atmosphere. So the atmosphere was pushing on the vehicle's flaps and everything else. And I don't think at that point the system would even actually release the ship because it's below such altitudes that I think the programming was not allowing for that. And so the vehicle was trying to get it up higher into a more elevated state before it did anything else. But I'm not sure if that was a intended role at the beginning or if that was still just an issue with the height there.
Again, another question before the launch. Why sink the booster instead of recovering it? From Joseph Wilson.
So at that point, the booster is not usable in any way when they were intending to do a soft water landing. But at this point, there is nothing to be able to be reused or even really gather. I suspect there'll be a debris field, but it'll just be a couple of COPVs that'll be floating around, but they'll sink or end up on the shore. So that, I guess, one other mention about the COPVs, I guess a PSA, is that they do contain carbon fiber, which can be an irritant, so you shouldn't touch those. But other than that, everything else should be basically sink in the ocean itself.
Kenneth K, another question before. I assume they would test a controlled landing on the water at Hawaii like the booster would.
Yeah, so that was our original expectations as well before they came out with the additional information or supplemental information with their launch license, which said that the ship's header tank would be empty, which would imply that they had, in orbit, had transferred or would have transferred their propellant from the header tank to a main tank, which basically means that there will be no way for them to land it. So the main tanks, when they would have basically been doing the reentry maneuvers, they would have dumped all of their propellants off the main tanks of the ship because it's supposed to land on the header tanks. But I think they're doing that propellant transfer, or would have been doing that propellant transfer as a test. So we didn't see that here today, but hopefully Ship 26 up next with Booster 9 will be capable of doing that for us, because it does have a header tank, but there is no way that vehicle will land because it doesn't have any thermal protection system or flaps to help guide and navigate it.
Question from Alu. Will I be able to see the Starship from Adelaide, South Australia? Assuming that it made it to flight orbit.
No, I don't believe so. It would be a little bit too far off the coast, I think, in Australia to capture it, unless you're at a high elevated position and just perfectly clear day all the way. Actually, it'd be kind of at night at that point in your position, so you may have been able to actually spot it. But the issue is, at this point, you wouldn't be able to spot it. It's only in the Gulf coast, about, I'd say, 20 to 30 miles or kilometers off the coast here.
I mean, it probably wouldn't be spotted because I think they were nighttime down there and probably wouldn't have no sun on it, so it'd be in the Earth's shadow.
All right, well, we've got another view here. Oh wow, is that the
Wow.
QD? They've got panels blown off of it, it looks like.
Yeah, those new doors they put on a few weeks ago.
That's one of those things I was really worried about, that it looks like it may have happened.
Yeah, the upper door is missing. The lower door is still intact.
I do wonder if it had a blowout from gases inside, or if it got ripped off from the just the sheer forces of the 33 Raptors just passing it. And maybe that's what hit the van at NSF. A big chunk of steel like that would take out the frame.
Well, it appears that the upper hatch has closed properly, and the ship, or the booster QD, has seated properly. So that just might have been torn apart from the thrust of the rocket pushing down on that door.
It has a thing above it that would be the arm for the door. That seems to be really relatively intact. It's a strong element there, but I do suspect there might be something with overpressurization event, basically an explosion inside of that QD housing that affected the door. Because all you need is a buildup of gases, and Elon has talked about a purge system on the vehicle. And I'm not sure if he's talked much about a purge system inside the launch table or other infrastructure, but wow, this is the first clean view we've got of all of this.
I think jumping to the conclusion that there was an explosion in
that's my presumption.
That's really bad.
Well, I have seen leaks of the hoses after they've done cryo tests when they retracted the QD system, like you would with a normal system, and they do build up oxygen because there is a leak on one of those lines that they have not replaced. All it takes is a same thing on the methane line, a small little leak there too would be an issue. Yeah, we've got a view of one of the little grass fires along the, looks like just next to the, I'd say that's the sand dunes right there, just butting up against the sand dunes. And so that's not unexpected for one of these launches. We've seen that happen for static fires as well. So it'll probably be a little bit before it can be put out or put itself out. The issue is once the site has been declared safe, they can then go ahead and send some water trucks over there to put it out, or they will fly drones above it that will have little packets of basically little exploding packets that will put out the fires. They basically contain non-toxic retardants that will smother the fire. They basically have these all over on TV or YouTube to demonstrate that you can put out like dumpster fires or all sorts of things. You just throw it on the fire and it heats it up, and it little basically pops, and you'll probably see a few drones going over there to help fix that. And that's basically the safest way to do it right now.
If we could pop over to Rover 2, you can see quite a bit of pieces of cabling hanging down, and and we're still venting from the ship, or the chill down vent on the right side of the leg there by the stairs. And there appears to be quite a bit hanging down under the or under the platform on the left between the legs.
Yeah, I see that looks like almost an electrical line or something on the legs. Actually, kind of surprised that survived as much as that did.
And then I'm not sure what all those 5 or 6 things that are hanging down. I don't remember seeing those before.
I think those look like they're part of the wrapping of the lines themselves. So we're just seeing basically sheets of like material that will protect the pipes. They're basically the insulation. So we're seeing some of that. I'm not sure what some of the thinner stuff is. The thicker stuff could also be some other tie downs or cabling stuff that has basically been removed from where it was at before.
One of the things between the legs is Bart's mount. That was one of the things you could see.
Oh, is that the chain you're looking at?
The chain was part of the lift, but then one of the actual mounts Bart goes into, you could see it hanging there also, and then other fiddly bits. I can't wait till we get some folks down there to get some good ground photos of the aftermath.
Yeah, it looks like we've got a drone flying over some of the fires, let's say locally to the, or where there was a fire. I don't see much smoke anymore, so I think it's burned itself out over at the pad. So that's good to see.
Well, Rover 2 certainly seemed to have survived very well, as did the VR cam over there.
Yeah, they held together very well. I do think Laz's windshield may have been damaged.
I'm looking at the gate between at the main entrance to right across from PagCam where it used to be. The gate's all blown down.
Oh wow, yeah. If we get a Rover 2 view, you can see it.
Look at the big rocks that are sitting around on the ground out there. Oh.
Now, we can't see that view quite yet. We'll get to it here in just a moment. But yeah, I still do see a little bit of residual smoke coming off of the area next to pad cam. But yeah, there's quite a few cameras that actually did stand upright. They were closer to the grass. So we did have quite a few survivors. That's good.
Yeah, some of the ones that are short, were on short tripods, seem to do fairly well.
Yeah. Yeah, so the fire, I guess that isn't quite out on that view. We can still see smoke billowing. It's not just going out. So I think that drone may have been actually headed for that. Basically, they're dropping those pellets. I can't remember what those are called. But yeah, there's just so much stuff that's happened here. You can just kind of see there's a piece of metal debris, looks like stainless steel, to the right. I'm wondering if that was coming from the booster itself, because I don't recognize anything on the launch table that would look like that. Unless it's piping, which that would be pretty bad, but I don't think it would be piping. Phila Kid, what do you think, or Nate?
I'm wondering if it just might have been a piece of material that was laying around that nobody picked up and it was over next to where Hoppy was, or along the back wall there or up on maybe up on one of the roofs of the containers there that nobody bothered to pick up. And I doubt if it was a piece of the booster.
Yeah.
I'm thinking it would have been one of the engine covers or something along those lines on the skirt, because we did see lift off some interesting pieces coming off of either the vehicle or the table or that immediate area. So that's where I'm just wondering about that, because it does look like a piece of stainless steel.
Well, we'll never find out, unfortunately.
Oh, I think Lab will be able to tell us later tonight. T plus 4 hours after all of this, he should be able to go through and collect camera equipment at the launch site, as long as it's been cleared.
Here's a video of the launch again, Thomas.
Yeah, this is fantastic. Every time I see this, I see all of the beauties of the launch itself, and I see the kind of the horrors of something coming up and going all the way up to the mid of the booster, up basically just next to the LOX tank. So something lifted up pretty high that was fairly large.
You know, I've looked at that several times. I think what we're doing is seeing a shadow underneath one of the vents. What we're doing is seeing a ullage vent at the top of the tank. And what we're seeing there is actually the shadow from the sun, the ullage over casting a shadow against the ice. I don't think that's something rising up along.
Well, because you see it rise and then you see it fall, and it doesn't match the.
No, it doesn't fall. It just dissipates as the ship changes its sun angle. It doesn't go back down. It stays with the ship.
This is where I wish I have the zoom and enhance tools.
Look at it in slow motion later. I don't think that's something that came off the launch pad or off the OLM and rose. I think it's just a shadow of the ullage vent on the side of the ship. I've looked at it a couple of times now, and I initially thought what you did, and the second and third looks, I say no, it's something else. Because there would be a hole in the ship right there, and there isn't one.
So John Kraus has a good picture that he tweeted out, and at that point there were 6 engines out, and there were 2 engines that were definitely off nominal. They're like a very light, faint blue color, where the rest are bright orange. So definitely had a lot out at that point.
Is that something you can share with the rest of us? We can look at it real quick too.
Out. Let me shoot it. At that point, there were 6 engines.
Thank you. Let's go through and get some more questions and get ready to wrap this up here. So at questions, if you have any last minute questions here that we can go through for you.
Let's see. I got to rechange my screen here.
Okay, I've got Planka 3430 asks, where are the tracking sat antenna located when Starship launches? They're just down Highway 4, closer to the village. So that is the location that the dishes are. There's two of those, and then there's actually one smaller dish that was on top of Mega Bay that would be able to track the booster all the way up and all the way back down if it was able to make a controlled water landing. I got the rest of the questions there, Phil Kid.
Yep, I'm good. Rockworm, why not build a separate practice catch tower away from the launch pad? A lot easier repair and wouldn't put stage 0 at risk.
Well, so far what we've seen doesn't indicate anything happened to the integration tower. I only saw perhaps a few pieces of debris around the launch table. But I think the real interesting question about a lot of this is why, you're to the main point, why do they not do a catch test with like a booster or some other smaller system to verify that it'd be able to catch a booster? Because you want to be able to do some sort of hover and then catch it and have some weights with it. You could potentially simulate that with a second system. It would be very difficult test with let's say like a crane or some other smaller system, other issues like damages. We've got that picture now from John Krause that you were talking about, Nate, because you want to be able to do some sort of hover and then catch it and have some weight. That is fantastic. You could potentially simulate that with
two of those engines that I thought were
system,
out are the ones that are off nominal producing the blue
let's
flame.
say crane.
It is amazing
other issues like damages.
That it performs
We've got
well
that picture now from John
engines
Krause
they
that
have
you were talking
losing.
about, Nate.
I mean, it just shows you how much thrust those Raptor 2s make.
That is fantastic.
Yeah,
I'm very
two
curious
of
to
those
figure
engines
out
that I thought were out are the
all
ones
of the
that are off nominal
issues that
producing the blue
occurred here. I
flame,
think there was
It is
stage
amazing
0
that it-
issues, in
that
my
it
opinion,
performed as well as
for
it did with the number of
needing
engines.
water. Oh, I see. You were listening to us live, and it was going through the cams. Oh, interesting. So the other part that we're now looking at here is the infrastructure on the launch table or the integration tower directly. I'm curious about those chopsticks, and everything looks pretty good on there.
I mean, those camera positions that are on the midpoints or the third points of the catch arms are still there.
I wonder if I see a couple of loose wires now on the right-hand side. I can't tell. It's just next to the right-hand side where it's a triangle on the lower stabilization point.
There are lines there and those lines curve, so they might be part of the hydraulic control system for that actuator arm.
Yeah, or it could be camera sensors or things like that need a bit more reinforcement.
Well, no, they actually look like they're functional. They just because they look like. Well, we'll find out later.
Yeah, we'll get some better details as time moves along here. So let's go ahead and answer some more questions while we're at it.
Robert Wells. if everything is go for launch, how well is the rocket during stress of Starship's test flight? What are your
Excellent, actually. That was a huge revelation today after launch. There was huge amounts of stresses, and it did extremely well.
Yeah, the interstage.
It
Wow.
went through max Q and survived, which is a plus. And they were able to throttle up the engines again. And so that from that standpoint, the structural stability of the ship was the structure of the ship was good. The stability control was an issue. And typically, an unstable vehicle it's rotating, and that could really break apart. So structurally, I think it was excellent shape.
Oh, by the way, I figured out what that venting is finally. I'm looking at rover 2. It's the area that they do for the pre-chill down of the methane lines. We can now kind of see that from this angle. It gives me that 1 degree that I needed to understand what we were looking at. So it is normal venting, which is really good to hear and feel now.
That's the pre-chill for the that happens just before they start to fire up the kettle boilers for the methane, right?
Yeah, this one is just right against the ground, basically next to the methane tanks, but it's close to that main heat exchanger that you see on the pipe that sticks up that's venting right now. That's just nitrogen venting off, and this is probably nitrogen as well. So yeah, it's normal behavior. That's good to see. It's just interesting how I'm looking at that going, well, where are they trying to recycle this methane from? That's the interesting part. It's warmed up, I guess, the tanks themselves, and they're just sitting there cycling the tanks. That's something I wasn't expecting.
Well, remember they always have ullage, and especially with the tanks venting, you're probably getting more ullage created as the tanks emptied and the gas forms. So you're always in the process of reconfiguring the gas back to liquid. So that's the process that happens whenever you end up with extra ullage that you have to capture and reformat to liquid, right?
Yeah. So, do we have any final questions to go through, and before we wrap things up here?
I have one final question here from Feed the Pups. Did the loss of engines cause the spin?
My opinion is that's the cause of the spin. That they were off nominal thrust in different directions, and so you had the issue of 2 things going on. One, you weren't as high in elevation as you needed to be, and so you also had aerodynamic drag because they were only about 35 kilometers up. There's still quite a bit there, and that looks like the vehicle did start to attempt the spin early, which was kind of interesting. But it was I guess a timing sequence on that side. And so at that point, it was spinning, but it was not ready to release for the ship. And either it held on or it was not programmed at that point to do the spin and release, which the timetable says it would have been. And the commentary from SpaceX said it would be. But something just was kind of off about that for the altitude of about 35 kilometers. They should have been much higher than they were at that point. So I think that's the key element that it just throws everything into it throws the wrench into the works, I guess you could say.
Yeah, as you watch replays, and they're not going to be replays we're able to pull up right now. Right before the ship begins to, or the booster begins to make that lurch, you're going to see a yellow, either, I would guess, one of the HPUs letting loose and hydraulic fluid being burnt, or possibly maybe one of the outside Raptors exploded, and things cascade down from there. There's all of a sudden yellow, much more of a yellow plume on the other side of the ring of engines at that point.
Right there.
Yeah, the HPU unit blew at that point, I think.
And even further up, you'll see something similar. And when it does that, that's when the booster starts to kind of just lisp out of control. It gets worse as it gets higher. So they definitely had some off nominal things taking place. I'm frankly surprised it made it as high as it did. It pushed through and did really well, honestly.
Yeah, I think actually Anomalia has it tracked at about 1 minute and 56 seconds here. That he believes the HPU blows out, and I would say that there's a large explosion or something like that as well. I did remember the red flames coming off of that, which would indicate high amounts of carbon. That it's basically the black body effect that you see there, and that's typically something like hydraulic units will use mineral oil, for instance, to do that, to do the hydraulic power to transfer from different areas. And so those lines, if it's leaking everywhere, that would be a good case or cause of that. So right here, coming up in about 16 seconds, we should probably see that.
Anyway, Adventuring Nerd had that question that just as you had brought it up there, Nate, that
Yeah,
it's
there it
20
is right there.
seconds on the left.
You can see it right there. That is definitely something happened. And then you can see the rest of it now. It kind of kind of moved around the ring.
Yeah, it's just right underneath the question there that we have on the screen, but it was visible that there was something on the side of the booster that was catching fire. So I think it lost HPU control right there. And that's what we're seeing right now, is that the vehicle is off nominal thrust and it's trying to correct for it. And I think it still has the other HPU active, but I'm not sure if it's connected on the same system and it has a automatic closeout valve if it loses power on one side, that it can just close it off, or what. But at this point, it's lost full control. It's out of control at this point. So I think you're right on the money there.
It's still amazing to me that the ship and booster stayed locked together. The way it was tumbling. We've had questions about how strong that interstage connection was, and I think that they at least proved that it is very strong.
Too strong.
Yeah.
Maybe.
Or maybe at this point they didn't want to separate it because they were, until they gained control of it, and it was easier to detonate it at while they're together.
Yeah.
Yeah, it kind of starts to, looks like fold right there or something, but it's still all in one piece. It's just the way that it looks with the venting going on.
But again, there's no structural
Yeah.
deformation of the entire ship. It's still functioning as a solid unit, which is amazing.
I really want to see that footage from the WB-57, especially at this point, and what their view was, because we have a lot of haze between us and the ship and the booster there. So there could be issues with the flaps or other things that are going on at this point. And then, yeah, that FTS looks like it goes off here on both the ship or the booster and then the ship. Oh, Hoppy, that's what we saw. That metal debris.
Yep, it was Hoppy's siding.
Yeah.
Yep, Hoppy took some damage, definitely.
But it's just the veneer. That's the funniest part about that. That veneer is just like super thin, and the rest of it, it's 12.5 millimeter thick stainless steel. I've seen a Raptor hit the top of Hoppy. You could still see the dent from, this was back with SN11. It just had a dropped Raptor on that point, and it barely put a dent on it. All right, so with that, I think we've wrapped up the questions here. I'll go ahead.
I did want to answer one thing. I'm sorry. I saw somebody on Twitter asking how far away the Rover 2 was, and we were right at 1,100 feet from stage 0. So just to see that amount of, that's almost, 100 yards from a quarter mile away, and that debris just came in like, it looked like a nuclear bomb went off there. That was insane. I'm just looking at a picture right now of the crater underneath stage 0, and it put a huge hole, maybe about 20, 25 feet deep. It blew out all the concrete. Crazy, guys.
Wow. All right. Well, with that, I'll go ahead and start wrapping things up. Thank you so much, Phila Kid, for joining us. Nate, Then we had Stephen from Spaceflight Now. Then Lab, you have been jumping in, so thank you for setting all this up and getting it all ready here. You've been a trooper. You even had a car tire just get destroyed on Highway 4 last night.
Oh, I know, my God. 2 cars now, 2 cars damaged.
Well, one of them is Highway 4's fault. The other one, just a little bit of debris, nothing much, but yeah, that's gonna cost you a little pretty penny there. Okay, the last person I forgot to think was Zach Golden, who also is Stage Zero Zach from CSI Starbase and RGV Aerophotography. He's probably out right now with Mauricio trying to get out some photos, so we'll hopefully see those later. And then also like to thank our supporters, so Sapphire Condominiums, Isla Grande Beach Resort, the finest combinations on South Padre Island, the wonderful city of South Padre Island for their extended support to La Padre, and In It Weather, SpaceX, and Elon Musk. We definitely can't thank them enough for this exciting day. Also can't forget some big supporters like Stumpy 001, John Heyman, and Crow Guy. Thank you for all their support. And of course, Lab, thank you again. It's been a pleasure to work with you on these launches. These are just amazing activities.
Yes, sir. Yes, sir. 3 bags full. This was this was a cool experience today. You know, as SpaceX always says, failure is always an option over here. I'm sure they got plenty of data to work on. They got a lot of work to do here coming up in the future. I'm not sure how long it's going to be before we see another flight. A lot of work on Stage 0, a lot of data to look through. But I definitely like to thank you all for helping us out as well. All the commentators, all the moderators, y'all have been awesome. All the viewers, all the people that have donated and sent money over our way to keep our stream going. You guys are awesome, and especially the mayor of Nerderville here, Phil Kohler, the Whiz Kid, aka. He's been out here at the Raptor Roost helping me out, and man, it's been a wild ride these past few days. So thank you all again for tuning in, and we'll see you next time.
Yeah, I'd just like to give a last shout out and thanks in general to just all of our mods and admins. Thank you, everybody, for keeping up with chat today. Thank you all so much. With that, I'll sign off. This is Thomas having a unrealistic moment of clarity of Starship's progress here. It's amazing.
This is Philly Fagan saying goodbye. Everybody have a great day. We'll see you the next flight.
I am NateZ. See y'all soon.
And Lab Padre is out.